And, just as a reminder, if you ever decide to take the networking engineering specialty, it is really the toughest of the exams, not in terms of breadth, just in terms of narrowness. PowerPoint has been doing some really interesting things today. I don't know if you noticed, but my hands were off the keyboard. I hit full screen about 3 seconds ago. Anyway, let's see if that continues. Does your organization operate in a hybrid environment, right? So what they're really asking is that, do you have basically some kind of like direct connectivity between your on-premise network and your AWS network? So do you guys use direct connect or VPN between the two at all? Do your customers? And then, of course, obviously you're dealing with customers who also have private data centers, on-premise data centers, and you have them doing public data centers. So, yeah. Oh, no, here's a better question. Oh, wait, so this is good, Mohit. I'm glad you said that. Let me ask you this. Do you have any customers who are running the same application across 2 clouds? Like at the same time? Like it's actually part of the same networking pool? Yeah. So I had to add this in as a model because, Amazon, when you take like, for example, Cloud Practitioner Essentials, they talk about, all in the cloud, private clouds, right? And then hybridized. And then we added another model called multi-cloud. The problem is that with multi-cloud, the systems operate so disparately that sometimes like running the same application with like 2 auto-scaling groups and using some kind of global load balancer to go between the 2 clouds, that's very problematic, right? And of course, why do you really need that? So, well, like Corey Quinn, by the way, is at reInvent right now. He's one of the guys who's pretty snarky about AWS. Talked about this whole definition of multi-cloud of like just being able to use multiple clouds for different workloads, but not running the same workload across 2 clouds. So Mohit, I'm going to be very interested to hear how that goes. Are you using an abstraction layer like Kubernetes on top of that, or is it just straight up like virtual machines and or serverless, like managed services? Yeah. I've done that before, by the way, for the NFL. I'm going to be very interested to hear how that goes. It was not one of my favorite times. All right, cool. Well, it's 2021, so that was 2 years ago. I hope your experience is different. Okay, so after setting up a VPN to AWS, you can resolve AWS assigned EC host names through VPN by default. In other words, the minute you connect a VPN into your VPC, does that mean that EC2 host can actually get back to your corporate network? Like just without changing anything else? Yeah, right. I mean, the answer is false because if you hook in another network to another network, by default, the routing table is going to say go out to the internet if I have a local address that I don't know, right? If that makes any sense. So then how am I going to make it so that I can find your corporate network? You got to put something in the route table that says that, hey, if you're looking for this network, you got to go over here, right? Don't go through the internet gateway, go through the VPN gateway, right? So the answer is false. You have to at least modify your routing tables to get that to function. Okay, I hope that kind of greases the wheels a little bit because we're going to start talking about networking. So, okay, here's our module map. So we're going to talk about really 4 things. We're going to talk about the overall project, which means we're going to talk about client VPN, which we're all familiar with, site-to-site VPN, which most of us are familiar with, direct connect, which is where you run a physical cable between yourself and Amazon, and then the Route 53 resolver, which is basically, how do you do DNS resolution inside of AWS? Here, by the way, notice they've got, for a VPN server, they've got a virtual gateway, which is option 1. And by the way, that virtual gateway's been around for a while, so that's like pretty common. Then they've got EC2, which is a completely unmanaged option, just so we're upfront about it, right? So that's not an official AWS offering. That's you rolling your own option with OpenVPN or whatever tool you're using, right? Or going to the marketplace. Oh, and by the way, one qualifier for what I said earlier about never recommending third parties. AWS will recommend that you go to the marketplace to grab certain things. So if they recommend their marketplace, that's the only way they're going to recommend third parties, but they will not name third parties by name inside their solution. Like, and say, hey, you should use Ping Federated, or you should use, Okta. They're not going to say that. They're going to say, hey, go to the marketplace and get the most appropriate third-party solution. So just as a little digression, they will refer to their marketplace. The reason that popped in my brain is that option 2 here with the EC2 instances, you can actually go to the AWS marketplace and grab Cisco devices and other like VPN solutions that will run on EC2. Has an option, but they're not managed solutions. They're completely roll your own. Option 3, which is relatively new for a lot of people, it's been around for I think maybe 2 years, is a transit gateway. So the transit gateway, think of the transit gateway has an awesome little gateway aggregator that you can use to actually manage and route multiple VPC and VPN and direct connect connections. So the transit gateway is actually just a crazy kind of meta routing option that will actually allow you to connect all these things together without having to do things like VPC peering and all this crazy, more complex routing. So we're going to talk about these in detail. So if you looked at these and said, Michael, I don't know what you're talking about, good, you're in the right place. Now, as far as the project call to action, basically what they're saying is that, our VPN connection isn't working. We need to improve it in some form or fashion. We need more consistency of bandwidth, which of course running anything over the internet is not going to be necessarily consistent. And then you got to create the VPCs in multiple regions, and you also need name resolution from on-premise into AWS, right? How's that going to work? So we'll talk about it. So what they want is that, Xiang Wei wants you to come up with a updated design. Here's the initial proposed architecture, like the initial project architecture is basically we're just connecting VPN together. No redundancy, no optimized DNS, right? Just EC2 based VPN connection from on-premise into an open VPN server inside your VPC. I know. It's boring. All right. It just doesn't have any of the ilities in it. So here are the project user stories that we're going to be rolling through is basically I want to, I want to connect to AWS without using on-premise VPN. I want to be able to optimize our VPN design, right? And so we want to make sure that we can go faster with it. On the left, you can see we're starting to use private zones in Route 53 to identify resources, but we want to be able to resolve to AWS resources. And then at the very bottom, you'll see that the network engineer says, look, we've got at least one level 3 app, which I have no idea what a level 3 app is. Maybe you know what a level 3 app is. Maybe, is there a level 4? Is there a level 1? What is level 0? Is level 0 the highest? I don't know. Anyway, regardless, what they're saying is that there's a critical app that we have going out to AWS, and we need to make sure the bandwidth is consistent, and we're going to have to minimize some risk, right, of connectivity loss. So these are the 4 kind of personas that they're kind of answering these questions for. Notice it's 2 developers and then a data center operations person and an engineer, a network engineer. So let's talk about this first one. Parth, actually, that's a good question. I would have expected layer 3 if they were doing the OSI model, but maybe, I don't know. That might be a good way to think about it, but I would have expected them to say layer 3 app instead, but so out of the 4 things we're going to talk about first, let's focus on client VPN because frankly, that's kind of the simplest and the easiest, right? So we want to connect to AWS without using our on-premise VPN to streamline remote development work. So that way, obviously, if people are remote, right? So AWS does have a client VPN service. It's managed, right? Enables you to securely access resources. You can use the client VPN for desktop, right? Which they have their own client. It really is just a kind of a reskin, a relabel, if you will, of the Open VPN client. Honestly, this works on Mac, Linux, and Windows. So, and most of us have used it throughout our careers. You can implement tons of security controls using what they call authorization rules to control how things are authenticated, what they have access to, whatnot. And it automatically has high availability and elasticity in it. So it will actually scale to the number of users on the back end. You can federate, by the way, using any of the standard sets. So Active Directory, any federated authentication. You can also use certificate-based authentication. Certificate-based authentication, I think uses the AWS certificate manager. So if you haven't used ACM, you'll get used to that if you decide to use client VPN. And all the standard like visibility, logging, custom security controls, network-based access rules as far as security controls, all of that exists. This does have deep integration with existing AWS services, specifically VPCs and the AWS directory service if you're using Active Directory. Interesting. There we go. So the setup here, by the way, is basically you're going to create a client VPC endpoint in the actual same region, right? Now, just to mention this, you're going to actually need a VPC with at least one subnet free. So you have to identify, obviously, I say free, it just needs to have a subnet in it. This is the subnet that you're going to associate with the client VPN endpoint, and you're going to note the CIDR ranges of that subnet, right? So you want to identify a suitable CIDR range also for the client IP addresses that doesn't overlap with the VPC's CIDR range. So visualize this in your brain for a second. You've got a VPC with 10 addresses in it. Let's say they're 10.1s because you're using the /16. Let's say the subnet is a 10.1.1 because it's a /24, right? Everyone follow me, 10.1.1. Just make sure, for example, that you don't have an overlapping range. And so you'll see this actually in this diagram here. The clients, for example, have a 10 range, which is /22 that they're using, but the subnet is actually using a /20, a 172.31. So to be very specific, this needs to be different from this.
Why is that?
Well, because the clients who VPN in are going to get assigned an IP address, right? And they need to be able to talk into that subnet, right? And they're not going to take IP addresses out of the subnet. They need to have their own network range. Otherwise, if, for example, they were the same IP address set on both sides, neither side would be able to find the other because they'd all think they were local networks. So in other words, if this was a 10.0.0.0 and this was a 10.0.0.0, they wouldn't be able to find each other. Because if I came from a client that was using 10.1.1 over here, it would also think to itself, oh, well, 10.1.1 must be on this subnet. It wouldn't actually think to go down the routing table and look specifically for the VPN connection to find it.
Gotcha. I was confusing what you were saying with the size of the CIDR block, not necessarily the range. I see. That makes more sense.
And there is a size limit. Like you have to use like at least a /27, and there has to be at least 8 IP addresses free on the subnet. But
I thought you were saying that you couldn't use 2 /20s. I'm like, that doesn't make any sense.
Oh, no, you can use whatever subnet mask you want, right? Yeah.
Okay.
Let's see. Does the client range need to be outside the VPC also? Yes. Yeah. You cannot have your client VPN CIDR range overlap with the VPC CIDR range, not necessarily the subnet per se, but the CIDR range. So I guess technically, Parth, to be technically specific, it's actually the VPC you need to avoid overlapping with, right? So for example, in this particular case, you could actually do a 172 like 30, for example, for your client range down here. Sorry, I know that's a lot. Let's do this. In other words, since this is the one you have to avoid overlapping with, you could actually set this to a 172.30, right? /16. Good. Now, notice here, what happens is that there's a client VPN network interface that's created. Why? Because if someone says that they're going to go look for the 10.0.0.0 address, guess what they're going to do? You're going to have an entry in your routing table that says, you know what? If you're looking for this particular address, right? You're going to go here, right? You're going to talk to the VPN network interface. Now, just to be frank, most of that's going to be set up for you. But if you were doing it manually, right, that's what you would do, right? Obviously, all of the restrictions apply. For example, so for example, if you have like something assigned, so this network card is probably going to have its own security group, and then if you have something assigned the perimeter, that could apply as well as far as inbound, outbound traffic. Just know that since this client endpoint is actually sourcing on a NIC that's inside the subnet, it's already inside your subnet. So make sure that you set your security groups and authorization rules appropriately to protect your subnet from that VPN traffic, okay? So that's pretty straightforward. That's just client VPN, probably the simplest of the ones to set up. So note here that there's a couple of components, right? So this is the VPN endpoint is the one that goes inside the subnet. It's going to end up having a NIC, right? This is where all the client VPN sessions are going to terminate, right? For the most part, the target network is basically the subnet. It's from a particular VPC that you're going to associate with the endpoint. Obviously, every VPN endpoint is going to have a route table that describes the available destination networks, right? So if you're like kind of getting through things, just to say this, by the way, you are not terminating this on a transit gateway, which actually offers more options. So just as a general recommendation, in the real world, you're probably going to use a transit gateway over any other option as far as like routability. The authorization rule is actually a very important aspect of this whole thing because it restricts the users in terms of who can access the network. There are no authorization rules, but with an authorization rule, it basically states like this is how the user is going to basically get authorized. And the rest of it kind of like makes sense. So think of the endpoint, by the way, as the entry point for the client termination. Think of the network interface as like where the actual output is inside of the subnet, right? So people are going to connect to the endpoint. They're going to establish their tunnel, right, using IPsec and IKE version 2. And then what will happen is that the tunnels will get set up. And then when they exit through that tunnel or tunnels, right, depending, you will exit through the network interface in the middle of the subnet or wherever you assigned it. Yeah. So as far as VPN ports, which is also another piece that's missing here, this is the standard 443 or 1194. Just to say this, your ports by default is typically TLS, so 443. You can enable connection logging. So yeah. The authentication methods, right, are interesting because authentication basically is implemented at the very first point of entry, right? It's really just determined like to, it's used to determine whether clients are even allowed to connect to the endpoint, right? If it's successful, the client is going to connect into the endpoint, right? And then everything's going to be like certified, right? It's going to be authorized and authenticated. So in this particular case, you can use Active Directory authentication. You can use a federated identity. And the last one is you can actually use mutual TLS, right? So as well, if you use a client certificate, by the way, just to mention this, I think I said this before, you're going to use the certificate manager for this. You oddly enough are going to have to specify the ARN, the Amazon resource name of the certificate in the mutual authentication box. So if you ever set that up, you do need the ARN of the certificate, not the certificate name, if you ever run into that. I think they fixed that, but it used to be labeled really weird. Notice here that the VPN endpoint is actually connected to some kind of SAML-based identity provider that's actually linked inside of IAM. So again, federation is supported. So you can actually have that federate to whatever system you're using, as long as it supports SAML. So as far as the exam goes, just remember that you can do SAML-based authentication here for client VPN, and you can do directly hook into Active Directory. So you don't actually need to use like federated authentication. Active Directory is directly supported using the Active Directory connector. Okay. So with a client VPN endpoint, right, this is where things get terminated. You can associate one or more target subnets, right? So, I said this before, but the subnet, and this shows up in the exam, must have a CIDR block of at least /27, right? So the bit mask has to be, /27, /26, /25, right? And the subnet itself has to have at least 8 available IP addresses. So it can't be smaller in a sense than a /27. So /28s and /29s are not supported. Obviously the CIDR blocks can't overlap with the client VPN endpoint. So, the subnet and the VPCs can't overlap with what you've assigned to the client IP address pool, right? If you associate more than one subnet, as is listed here, with a VPC endpoint, with a client VPN endpoint, those subnets have to be in different availability zones. right? Sometimes they'll catch you on the exam by saying that you play, we hooked you up to a bunch of subnets in the same availability zone. The client VPN side, the subnets have to be in different availability zones, right? The other obvious things that sometimes they grab you with is that if you're on a client VPN endpoint and when you create the endpoint, the subnet has to be in the same VPC. I know that sounds strange, but when you associate it with a VPC, you can't choose a subnet that's outside the VPC. Right? Does that make sense? Subnets go inside VPCs. So if you've created an endpoint with a VPC and with its associated subnets, it needs to go in there. Now, by the way, you can do peered VPCs. So you can also say, hey, this VPC that I'm VPNing into is associated. It has a peering connection with another VPC. You can add that as a target network as well, right? But remember, the VPC has to be connected to that other VPC, because all your traffic, when you VPN into a VPC and into a subnet in a VPC, all that traffic has to stay like routable within the VPC. So if you're trying to get to another VPC and you don't have a peering connection with that VPC, you can't get to it. Imagine you're in that VPC and you're trying to go across the network. If the VPC itself doesn't have a connection to the other VPC, then VPN's not going to solve that problem for you. I hope that makes sense, right? It's not a panacea. If the VPC itself doesn't have connectivity to the other VPC, adding VPN isn't going to change that, right?
But you are still saying that the peering is going to allow two VPCs. I mean, the VPN users to access both the VPCs.
Yes. In other words, it can still actually get to the VPC if peering is present.
Yeah. Okay. I mean, VPC peering is always kind of tricky. It doesn't allow certain things to happen. So. Yeah.
Right. Like transitive peering obviously still can't occur. Right. So, but obviously, if you have a direct connection from this particular VPC and its subnet, you can actually get to the other VPC. And I got to tell you, just to say this, is that Transit Gateway, if Transit Gateway is in play in any of this, Transit Gateway will enable you to get wherever you want to go. But remember, it has to be a network that's available to the client VPN. You have to specify that has an available network for the client VPN users to get to. Just because the VPC peering connection is there doesn't mean that the users can actually get to that other VPC if you haven't authorized that inside of the VPN settings. Does everyone follow me for that? Just because the network can get everywhere doesn't mean that someone who comes in from VPN can get to the same places. You actually have to, in a sense, create an allow list or a whitelist that says, hey, VPN people, you can get to these networks, right? If you don't do that, they can't get to the networks, even if the networks are available.
And that's through like an authorization role, or is it the?
Yeah, through an authorization role, right?
Okay.
Yeah. Good. I was speaking clearly. I like that. All right. Good. So in this particular drawing, you can see it getting to a subnet and see it's actually getting to like the internet and other AWS services, and it's getting to an on-premise network, which it looks like it's doing that through another connection, oddly enough. And then there's VPC peering. Transit Gateway could be here as well. Okay. It's one thing that's kind of missing. Remember, with client VPN endpoints, you've got a client on a desktop and you're hooking into AWS. So this is not site to site. This is not network device to network device. So I hope everyone's following me, right? This is all like end user devices using a VPN client to get into a VPC/subnet. Okay. So this is all client stuff, not network device to network device. Okay.
To make it further complex, this VPN can use, yeah, I think you said so. This VPN can use like any SAML providers as SSO, right?
Yes. So as long as it supports SAML 2.0 and it's federated in with IAM, right? You can actually access it through, we use client VPN as its authentication mechanism.
Yeah.
Sorry, I was confusing authentication and authorization there for a second. If you're using Active Directory, by the way, it's just a checkbox. It's just directory ID. So you don't actually need to use the SAML, like the federated authentication, even though obviously Active Directory will support that. So, okay, That's client VPN. I warned you. We're gonna talk about networking. We're gonna keep going. We've just started to get, we just got a few stairs down this rabbit hole, actually. All right, so let's talk about site-to-site VPN. Here's the user, by the way, who's concerned about this. We need to optimize our VPN design. Our VPN connection to AWS is 75% busier than it was this month and last, right? It's only going up. So this is where site-to-site comes in. Now, again, you've got the same options, except a little different. So remember, when we were looking at client VPN, here are our options. Well, this is where we started at least, right? The virtual gateway, right? The EC2 box, which is an unmanaged option, not recommended, but AWS acknowledges that it's there. And then we had the transit gateway, which is option 3 down there, right? So literally the diagram that we saw at the beginning, this is where we're at with site-to-site VPN, is that we are actually literally talking about these 3 options. So what this means is that if you have a networking device in your data center, obviously that supports IPsec and IKE version 2, right? Which actually make up the VPN protocol. Let's be clear, in case you haven't heard that before. IKE version 2 combined with IPsec make up the VPN protocol. Now you can replace those with GRE and other protocols, but Amazon supports IPsec with IKE version 2 as its main methods, right? So you can connect to a virtual gateway, which again is just a networking endpoint, a gateway really inside of your account under your, when you go into VPCs, right? The other option is that you can turn on transit gateway. The cool thing I just want to tell you is that we actually do have a lab where we're actually going to do transit gateway. So that's going to be awesome. Which is going to be fun because transit gateway is like super powerful. I actually also have a free lab for that as well. So later on, I'll make sure you have those resources after you take your exam. So by default, instances that you launch into a VPC can't communicate through your remote network. In order to enable access, people typically go for a site-to-site VPN. So you can get back to the corporate network, using one of these 3 methods. All of this, by the way, is generally just about connectivity and routing. So it's just VPN connection, and then how do you route across these connections? I'm going to refer to this, by the way, as a VPN connection, but what I'm actually saying is a site-to-site VPN connection. So if you hear me use those terms, I'm talking about device to device. Now, one of the options to do, like for example, let's say a Cisco device or like a TP-Link or whatever you're using into AWS, is to connect to what's called a virtual gateway, right? Now, what's interesting is about a site-to-site VPN connection. A site-to-site VPN connection actually has 2 tunnels connected to it, right? I know that sounds weird, but it's like 2 encrypted tunnels that you can use, between the virtual private gateway, which is listed here, or transit gateway, if that's one of the options, and then a customer gateway, which represents the VPN device itself, right? So this is going to generate an IP like sec site-to-site tunnel, and I think does it not say on the side? I guess it doesn't actually. It's like AES 256 and SHA-2 and the latest Diffie-Hellman groups, right? So it supports predominantly the latest encryption. And so, by the way, each of those tunnels, so one site-to-site connection is going to create 2 VPN tunnels. Each of those tunnels, by the way, if memory serves, is 1.25 terabytes in speed. So, obviously, if your network connection doesn't support that speed, you're not going to get that. But on AWS's side, they'll support that 1.25 terabytes. That sometimes shows up on the Pro exam, by the way, where they're like, "Hey, I need a 5 terabit connection." So, by the way, if someone says they need a 5 terabit connection and they need consistent bandwidth, what are you going to use for that? You should already know the answer to this without having to know the Pro material. They need a 5 terabit connection and they need dedicated consistent bandwidth. What are they going to use? So they're going to use VPN or something else?
I mean, direct connect.
Direct connect. Yeah, so if that's what they're going to use, they're going to use direct connect. Mohit, I'm not familiar with dedicated peering. That might be something new that I'm not familiar with, unless you were referring to direct connect, which is actually a form of dedicated peering. Right. So 1 gigabit, 10 gigabit, 100 gigabit speed. So we'll talk about direct connect here later on, but I just wanted you to know that if you need consistent bandwidth, it's not affected by internet weather, VPN is not going to be your friend. But each site to site has 2 tunnels that can max out at 1.25 terabits per second. They say terabytes, I meant terabits. So note that there are redundant endpoints on the AWS side because there's 2 tunnels, right? So they're gonna like they're gonna create redundancy automatically. Some other things. You can use static or dynamic BGP routing, which honestly is recommended that you use dynamic, so that's not really supported. It says it supports either IPv4 traffic or IPv6 traffic inside the VPN tunnels. That's technically correct, but I don't think that IPv6 traffic is actually supported on the virtual private gateway. I think you actually have to use transit gateway to get IPv6, but these VPN connections are not going to support path MTU discovery. So if you need that kind of thing, it's not going to work actually. Other things to note: can the CIDR blocks overlap between your VPC and your corporate network? No, they can't. And I mean, don't get me wrong, you can figure out a way to make it work on a per host basis. But if you're using 10.1.0.0 and it's a /16 on the left, using 10.1.0.0/16 on the right, that's not, the networks aren't going to know how to find each other. They're going to keep thinking they're local, right? So just kind of basic IPv4. Notice it says support for IKEv2 and NAT-T. I like that it says that it has support for IKE version. It's actually required. It's not supported. You have to use IKE version 2. So I'm not really sure what they are doing with that. As far as like there being redundant endpoints and it being about 1.25 terabits and terminating the connections in different availability zones and using static or dynamic routing. The only other thing that really clearly stands out in the exam is that it can support IPv4, IPv6 traffic, depending on what you're terminating on, right? So just know that it will, technically from Amazon's perspective, it will support IPv4 and IPv6. You just have to use a different termination point actually. Okay, so that's option 1, where your network device connects to a virtual gateway. Option 2 is where you connect to an EC2 instance. We're not going to talk about this a whole lot. 1, it's not covered on the exam, but the reason this is offered as an option is that if you need more control over, like, because the virtual gateway is pretty much a structured like PaaS service. You don't get to control all the little low-level details. If you need control over all the low-level details between your corporate network and the terminating point inside your VPC, you're going to roll it onto an EC2 instance, right? The other reason that you might consider rolling it onto an EC2 instance is that you're not supporting IPsec. You want to use GRE instead. Why you want to do that? Someone smarter than me can probably tell me, but I haven't come across a use case where you're not going to use IPsec, but maybe someone else has that. Can explain that. Okay. All right, here's number 3. So number 1 was device to virtual gateway, right? Number 2 was device to an EC2 instance. By the way, that EC2 instance could be from the marketplace with like Cisco running on it, right? Option 3, device to a transit gateway. So think of the transit gateway as a simplified hub with like burstable throughput to all of your VPCs, all of your VPN connections, and all of your direct connect gateways. Okay. So just know, like, to attach, your VPN connection to a transit gateway, you just have to specify the customer gateway in the transit gateway, right? So this, allows you basically to route through the transit gateway to all of your other connections, right? Yeah. You can do it like static and dynamic routing. I gotta tell you, transit gateway can get really complex just in terms of like the number of things that you can connect to it. But setting up transit gateway and using it is actually remarkably like simplified. So it really is a better option if you've been doing VPC peering inside of a VPC. It's also a better option if you've been doing all this like routing jury rigging with the customer gateways to create multiple VPN connections. So it's rare when AWS publishes a service that's just so incredibly better than what they already have that you're like, man, this is a clear winner, right? So, and it is.
Is there a cost difference between the virtual gateway and the transit gateway?
It's mainly a bandwidth shoved through, and of course the bandwidth limitations, right? So, each tunnel is limited to 1.25. The transit gateway has a huge, like, is virtually unlimited set of burstable capacity in it. right?
Sorry, financial cost.
It's all bandwidth based, so there's no difference.
Gotcha. Okay.
Yeah, this is just a structure, right? The arrow should be both ways between TGW and VPC. Oh yeah, yeah. If that was the question, Saran, yeah, absolutely. In other words, your VPCs can route back to the site-to-site VPN, so it should be bi-directional. Yeah, I'm not sure why it's not. It should be. Okay, now one other thing that they sometimes mention is that what if we want to scale site-to-site VPN traffic, right? You know, or sorry, scale. What if you want to be redundant with your connections, right? This is the simplest way to do it is you just set up, with 2 different devices, you just set up, right? Basically 4 tunnels. Because remember, every site-to-site VPN connection has 2 tunnels inside of it, right? So this shows basically them using 2 site-to-site connections, right? With 2 customer gateways. That's not going to be a surprise. This is the simplest, right? So if someone, if you get an exam question that says, like, what is the simplest way to set up redundancy for, VPN connections for site-to-site VPN connections? Usually it's just going to be just add a second VPN connection with a second customer gateway device. That's it. Now, what if you want to scale them? What if you're like, I really want to start maximizing my bandwidth because I don't want to pay for a direct connection, right? With transit gateway in particular, remember, wait, did I say terabits? I'm sorry, 1.25 gigabits. Man, my brain is in a weird place this morning. I apologize. So each VPN tunnel is 1.25 gigabits. I'm glad that's on the slide. I would have had to come back tomorrow and apologize. So notice that with the customer gateway, what's happened is that they have multiple like VPC and VPN connections going between the VPCs, the transit gateway, and they're basically just stacking VPN connections. Now, of course, your network bandwidth, like your connectivity to the internet, is going to have to support that 1.25 gigabits per connection, right? So, obviously, if you want to stack these together, you can. Note, by the way, that these are by default are not going to be aggregated unless you use what's called ECMP, right? And these are just independent connections. So this could be traffic could be like manually routed across these 2 connections. If you use something called ECMP, right, which is enabled through Transit Gateway, and you also have to enable it on the gateway side. So both sides have to support ECMP. What this does is you can stack multiple VPN connections at 1.25 gigabits per, right? And what will happen is it's basically equal cost multipath routing. That's what ECMP, right, supports. Is that it's the equal cost multipath routing protocol, right? So what this does is it basically is going to try and like route traffic with equal cost across all of the number of VPN connections that you have here. So you're gonna have you could have 4, 5, 6, 7, 8 to like push up to that, let's say 10 gigabit connection that you were looking for. It does do specifically what's called 5-tuple hashing. Oh my God, let's see if I can get this right. Protocol number, source IP address, destination IP address, source port number, and destination port number, right, are going to be the 5 things it's going to like do a hash against. By the way, they're not going to ask you that on the exam. This isn't the network engineering exam, right? But just know that if you want to equalize your site-to-site, you want to use multiple VPN connections and you want to equalize the usage of them, you're going to have to use ECMP. That does show up on the exam, right? Where they're going to say, a customer has 4 VPN connections between their corporate data center and a transit gateway, and they're having trouble getting the flows to the network traffic to even out across the 4 tunnels. How would you fix that? And they're going to say, you're going to use enable ECMP, right? Even if you don't remember it, they're going to say ECMP, right? Which is going to be equal cost multipath routing. Notice, by the way, the transit gateway is talking to ENIs, because by the way, that's how transit gateway does it, is it actually sticks network cards inside your subnets, right? So just be aware of that. And notice here that it's talking to ENIs inside these 2 specific private subnets, just has a endpoint, right? So not only like, obviously these are VPN endpoints, so these are actually set to those network interfaces, but also know that Transit Gateway also sticks network cards inside the subnets as well. I don't know if there's anything else to say about that. Oh, this is fun. Okay, so another thing that you can do, like if you want to enable acceleration, like I know this is gonna sound, if you want to go faster with your VPN connections, oddly enough, like if you want to accelerate them, you can actually, there's a box inside of the site-to-site VPN connection option that basically turns on Global Accelerator to basically route your traffic from your on-premise network onto an edge location. So you're still going across the internet, but you're going to an edge location, you're getting hooked into the edge location, and then you're going to run over AWS's backbone. Everyone following me? So instead of running just straight across the internet, what's going to happen is that you're going to go to the closest edge location, and that's how your VPN traffic and connection is going to flow, which means you're actually going to go over AWS's backbone, which is going to be faster than the public internet generally, right? Global Accelerator does this by basically routing you to the most appropriate edge location, depending on kind of where you're coming from. So if they've got an edge server close to you and you turn on acceleration, your VPN traffic is now from site-to-site VPN is now going to route through the edge location and get back to AWS. The
You
only
said generally,
go
you
ahead.
said generally, so there could be kind of edge cases. So they're in Montana, the client, North Dakota, South Dakota, probably.
Yes, you're right on, Brad. There are edge cases. I've only had this one time, and we were in Wyoming for a military thing, right? And they wanted to test this just to see how it would function, right? This was recently, and guess what? It wasn't faster, right? Because we're in the middle of nowhere, right?
Yeah.
Where was the nearest edge server, right? Since they only stick edge servers near major ISPs, where was the nearest edge server, right? Well, it turns out there, don't repeat this. From what we could tell, there wasn't one in Wyoming. So we went to another state. So at that point in time, we were just like, well, we're just going to use our, because I think it bought us like a couple milliseconds of latency. That was it. So in general, though, like it's going to be faster. It is if you're not out in the middle of nowhere. But if you're in a remote Pacific island and there's no edge servers there, so you should probably just stick with your site-to-site VPN. One other thing to mention is that when you turn this on and they give you an Anycast IP address, be aware that you cannot manage this like you manage Global Accelerator, because you're not really turning on Global Accelerator, you're turning on Global Acceleration for your VPN connection. So don't expect that you can go in and manage this into the Anycast like console interface. You're not going to be able to do that. This is a checkbox inside the client VPN. Okay. Okay, so that was all site-to-site VPN focused on ways of creating redundancy, using ECMP to create optimizations for increasing bandwidth. This is all over the internet. And of course, don't forget about VPN acceleration, which uses Global Accelerator, right? And please note my earlier mistake. It's not 1.25 terabits, it's 1.25 gigabits. Not sure where my brain was at, but we're gonna make sure that stays accurate. Yeah, so that's all site to site. So we've talked about client, we talked about site to site. Let's talk about Direct Connect. So Direct Connect, if we're talking about the one level 3 app that we have, and we need to have consistent bandwidth and minimize risk from potential loss of connectivity, Direct Connect, obviously, when it comes to consistent bandwidth, just cannot be beat, right? So, this is going to obviously be, you can see it, it's in, 110 and 100 and what they call fractionated links, like gigabit links, right? So it creates a fiber length, fiber connection basically from the customer data center to Direct Connect, to the Direct Connect location. Note that here they are connecting to what's called a virtual gateway, right? Which we've been looking at before. It can actually be a Direct Connect router as well. This Direct Connect location is associated with a region. Now, with this connection, just to mention this, is that you can create basically what they call virtual interfaces like directly to either public AWS resources or to the VPC, and you can bypass the internet service providers in your network path, right? So it does, by the way, is directly connected to a region, and you can use a single connection in a public or region or a gov cloud to access services in pretty much all of the other regions as well. So you can actually route to other regions, but it is terminated at a specific region. So 10.0.0/8 going into a 172.16. Looks pretty standard. Here's a little bit more about the architecture. So your network, by the way, has to meet one of the following conditions, right? It has to be able to get to what's called a direct connect location, right? And you have to be working with a DX partner, like a direct connect partner who is a member of the AWS partner network, right? And so and you have to be working with an ISP, an independent service provider, right, to connect to direct connect. Direct connect is going to support IPv4 and IPv6, right? And so IPv6 is going to, addresses are going to be like provided by the it can be accessible through AWS. There are some limitations on weird things like frame size and whatnot, but like that all gets handled when you set it up. That's not going to show up on the exam, so I'm not going to dive into it. And you can create virtual interfaces, right? Which can be tied to VLANs. So for example, let's say that you want to tie your VLAN in a particular like customer router, right? Sorry, let me explain that again, just to make sure we're clear. You're going to run a fiber connection to a device that's going to be inside of an Amazon partner network. They in turn are going to work with you to connect to the what they call a direct connect router, and they're going to run a cable out to the region. You're not going to see where that's going or how that's set up, because Amazon doesn't want you to know where their data center is. Everyone following me? Amazon doesn't want you to know where their data center is. So you're going to go to a partner data center. You're going to put a device in there. You're going to terminate your fiber in with that device. And then they're going to provide you from there your connectivity to AWS. That way Amazon can hide where their data centers are, because you don't know where your stuff is, right? Right. And just be clear, you can go on Google Maps and find Amazon data centers. So now you're in basically the direct connect location, but you're connected to your router or your device, right? And you've created some VLANs because you want to have certain traffic routed in certain ways to AWS. Notice here in purple, right? You've got a public virtual interface that matches the VLAN on your router so that it can actually go to a public endpoint. That's everything in purple, right? That is a public virtual interface. Notice that all of the other interfaces that match the VLANs, the black, the blue, and the purple, those are private VIFs. Why? Because they're going to Amazon's internal network. Public VIFs going to go to public services. Private VIFs are going to go to private services. By the way, you can bring your own IP addresses and other stuff to this. You can bring your own public ASNs. None of this is on the exam, right? I'm just sharing that with you. The only thing that is on the exam is that you need to use a public VIF if you're going to public services, and if you're going to private resources, you want to use a private VIF. That's on the exam. One kind of like interesting caveat to note is that even though that's a public VIF going to a public endpoint, it never leaves AWS's private network. So then why do we have a public VIF, Michael? Why, Michael, do we have a public VIF? It's never going to hit the public network. I'm just kidding. That's just the way it works, right? It normally actually would go across the public internet, but Amazon is routing it privately. So even though it's going to public endpoints, they're taking care of that for you. It's just an extra benefit they offer to you to reduce any security threats. Your traffic is never going to go across the public internet, even if it's going across a public VIF and you're accessing public services.
Didn't I see on the other slide that the traffic was not encrypted?
Yes. Well, yeah, it's not encrypted. You got to encrypt it by default, right? It's not encrypted by default. You have to encrypt it. Most people forget that just because it's run over private cables doesn't mean the traffic inside is encrypted, right? Now you might say, well, is that a problem? Well, it could be. If your requirement is that for all traffic be encrypted, it's a problem. If you're like, then you, right? But just know that it doesn't encrypt it by default, unlike VPN, of course, which does encrypt it because it's running it across the internet. Isn't that weird? If we're running across the internet, we're going to encrypt it. But if we're running it privately, it's going to run across the cable and we're not going to encrypt it.
Yeah, I'm surprised by default it's not encrypted. I would expect the encryption to be the default.
Yeah, I think mainly because these are considered to be private cables,
Yeah.
only shared by you. But I gotta tell you, I don't know of anybody who doesn't encrypt their traffic across
Right.
these direct connect connections. So, yeah. Okay. Now I mentioned this already, right? You've obviously got public VIFs, which are used to access public AWS services. Then you've got private VIFs. These are virtual interfaces, right? By the way, right? Think of these as egress points, like termination points for how you route inside of Direct Connect. Public VIFs are going to go to public endpoints like S3 and SSM and all that. Private VIFs are going to be where you're talking to VPCs, right? Using private IP addresses. And then transit VIFs basically are used to connect transit gateways right in as well. And I got to tell you, once transit gateways get in, you got a lot of options at that point in time. I feel like there was something I was supposed to tell you about transit gateways and transit VIFs. They don't support 100 gigabit connections. So you're not going to shove 100 gigabits of connectivity through a transit gateway. Okay. So those are the three options: public VIFs, private VIFs, transit VIFs. So just remember that does key up on the exam. Okay, here are some direct connect VPC connection options. So just different types, right? So we got the customer cage talking over to the AWS cage, and then you just create logical routes to like different resources. So option one, we've got a private VIF that's talking to your virtual gateway. We've got a private GIF that's talking to your direct connect gateway. You might say, Michael, what's the difference? A virtual gateway, by the way, can handle like VPN connections and other things. A DX gateway, which is a direct connect gateway, can only handle direct connect connections. What are you going to use? Well, Michael's going to tell you that you're going to use a transit gateway, right? Because it's just going to give you a whole bunch of options that you may or may not even know that you need, which is option number 3, right? So if you can, just try to use a transit gateway if you ever get into that. It's going to offer you a lot of future flexibility, and there's really little to no downside. The only reason you wouldn't do that, by the way, is if you're doing a 100 gigabit connection, and then you're not, as of today, I don't think you can run that through a transit gateway. It's not going to support your full amount of bandwidth, okay? Notice that these were 2 privates for the first 2 options, and then a transit VIF for the third option. And then we've got, VPN over a public VIF, right? So kind of interesting. Notice that transit gateway can be brought into play in most of these. Even with the virtual gateway and the DirectX gateway, you can actually get transit gateway involved. They didn't show this in this diagram, but in options 3 and 4, they've gotten transit gateway involved, even though, for example, you've also got VPN involved, right? So I like different connection types for different results, right? Okay, let's review this a little bit. So here, option 1, we got a private VIF to a virtual gateway. So this is going to provide access to resources like a VPC and the private IP addresses. Just so you know, a private VIF is not going to let you talk to VPC endpoints. Why is that? Because if you want that, you're going to use a public VIF, right? This is what public VIFs are for, right? Public VIFs are for you to talk to AWS services. So you're not going to route into a private network and then use the VPC endpoint to get to public services. They're going to tell you to use a public VIF if you want to do that. Don't create a double route. They're not going to, like, I don't know, like they're like, don't do that. They're basically like, just use a public VIF. In other words, route stuff that comes in through your direct connect connection instead of going to a private subnet, then going to a VPC endpoint and then using that to get to public. Just route that traffic directly over to a public endpoint. That's what public VIFs are for. So just so you know, when you use a private VIF like this, you cannot route to a VPC endpoint. That was what we did in the lab yesterday. Remember, we were routing to endpoints. That's a way to get a private subnet to talk to public interfaces. Amazon's going to tell you in this particular connection, don't do that. Route your traffic through a public VIF if you need to talk to the AWS services. They'll still keep it private. Okay. So this is option number one. By the way, you can access things that stick network cards inside other than endpoints. So for example, if you have an Elastic File System, which some of you should know is basically an NFS server for Linux, you can actually access that here. You just can't access endpoints. That's all. Option two is not a private VIF to a virtual gateway. It's a private VIF to a direct connect gateway, which was previously shorthanded to DirectX, right? So a direct connect gateway is a globally available resource. You can create them in any public region. You can access it from any public region. And so you can then associate this, by the way, with a transit gateway or associate it with another like virtual private gateway. Just think of the direct connect gateway as a termination point only for direct connect connections. Most of the time, I only see people using this if they are using a 100 gigabit connection. If it's smaller than that, they're either going to terminate on a virtual gateway or they're going to terminate on a transit gateway. And then option three is that now we're going to like route and terminate our connection basically into a direct connect gateway and then to the transit gateway. So kind of what I was talking about just a minute ago, right? So this is going to then allow you to create a single connection to all of your VPCs, because the transit gateway that can then talk to all the VPCs you want. In this setup, the transit gateway is going to be somewhat limited, right? So transit gateway is going to allow you to talk to all of your VPCs. And then last but not least is that, you know, with Direct Connect plus VPN, you can basically combine one or more Direct Connect like dedicated connections with the Amazon VPC VPN connectivity. So this is what this is going to do, is that this is going to provide an IPsec encrypted private connection that's going to run through the tunnel. So if you don't want to encrypt your own traffic, you can also just run a VPN tunnel through the Direct Connect connection. So Brad, speaking to what you talked about before, that would be a way to encrypt traffic. That's what most people end up doing, right? So, and since the VPN is a managed service provided by AWS, the only thing you have to worry about is what's going on the client side, right? You obviously have to manage your own network devices, like your VPN router or whatever. That's it. Notice here the VPN attachment is running right into a transit gateway. Because again, at that point in time, once you get to a transit gateway, you can talk to all of your VPCs, you can talk to other VPN connections, you can talk to other direct connect connections. Transit gateway is going to allow you to route to all that stuff.
A naive question, when we're connecting to the VPCs and the workloads, and presumably in this case, it's predominantly going to be like probably databases or EC2 instances or something similar to that type of data. Mm. Is that a correct assumption for what the kind of high level use case would be for these connections?
Yeah. For example, you know, let's say that you have certain data processing out on AWS and some on your on-premise data center. You're probably going to be pulling or pushing or kicking off data jobs in those two locations, right? Yeah. So yeah, it's for bi-directional access to resources. Were you thinking of another use case?
Just like in terms of, you know, you wanted to use some of the other like managed services, you know, Pinpoint, potentially Lambda, something like that, where it might not be data driven, but more like an app setting or an app, part of an application.
So with interface endpoints, you know, obviously you can't directly get there right from a VIF, right? You'd have to go through a transit gateway to get access to it. But like, you know, you could privately access all of those endpoints as you see fit, or you could just use a public VIF and just access them privately over the public interface, right? So it doesn't just have to be about data exchange. It could be you triggering services, or there's really no limits, honestly, Brad. Like, you're connecting two networks together. The only limit is the permissions you set up.
So just to be clear, like we we would kind of deploy an RDS in a private subnet, right?
Right.
So that's what we do. And then the RDS, if we back up and if we get data, we also do an endpoint, S3 endpoint in the private subnet or within the VPC.
Mhm.
But when we need to bring on-prem access, that has to be a public VIF to the public subnet.
Yeah, in other words, when those calls came in from the corporate network, your VLAN settings inside the partner network would actually push you across the public VIF, which would then have you accessing the public API. Whereas if you were just going to the database, you would just route to the database. You would go through a private VIF instead. And that would all be set up from your network settings, the VLANs and other routing that you set up on your customer gateway to the direct connect connection. Does that
Okay,
make sense?
I mean, the interesting part of it is what we call like an endpoint, right? A S3 endpoint is sort of either it's also ENI or it's a routing table entry, right?
Yeah, depending on whether it's a gateway, right, or an interface endpoint.
Yeah.
Remember,
so
S3 and DynamoDB are the only ones that can do that. Everything else is a network card interface endpoint.
Yeah. So I mean, if it's an ENI, right? It's a ENI. So let's say if a S3 is an ENI in a private subnet, right? Then the on-prem traffic can just be terminated in the private subnet as well, and they can access seamlessly.
Well, remember I said earlier, right, that this like private VIF option can't access endpoints. Remember?
But if it's the private IP, right, then like if it's like 10.10.10.5 and the VPN is terminated to 10.10.10.6, then why can't?
Because they've designed it so it won't accept traffic if you're trying to come from a VIF into an endpoint, right? That's what I'm saying, Saif, is that there's a technical limitation that they've imposed. They're going to force you to use a public VIF.
Okay.
I understand what you're saying, that from a networking routing possibility, why wouldn't they just be able to do that? I don't know why they're not doing that. They just don't allow it.
Okay.
In other words, they want you to use a public VIF to get that instead of routing through a private VIF, then to an endpoint, and then hitting the public interface.
Okay, and why once they say that, it's like, you know, the termination to public VIF and like public subnet still ensures the traffic doesn't go outside of AWS, right?
Exactly. Yeah, because when you run it through a public VIF, even though it says public, they're actually not running you across the internet. They're still keeping it on AWS's backbone.
Yeah, but it's kind of counterproductive, because then the whole point of pushing people to create S3 endpoints, right, in the VPC is kind of pointless, because, you know, it's the traffic technically doesn't leave AWS either in that
Right.
case.
But it's not useless, right? What it means is that the systems that are in that subnet actually can access the VPC endpoint and get access to the services. What they're actually forcing you to do is not only increasing extra hops to their services, but they're simplifying it, because you'll have to create an interface endpoint for each of those services that you want to route privately to. If you're coming from a corporate network, you're going to be accessing a broad range of services. You would have to set up a interface endpoint for each of the services you want to access. What they're saying is, don't do that. Just route everything through the public VIF. If you're going to public services, we'll just give you one construct. You'll just do that instead of setting up 30 constructs for 30 services. So it actually does make sense, Saif, that they're asking you to do that, because your corporate network isn't just going to be application traffic. There's also going to be management traffic coming from it. So that's why they're recommending you go that route. But it doesn't make the endpoints useless. It makes them relevant for the services that are inside the subnet, right? But I mean, I see what you're saying, because you're like, why wouldn't they just allow it? I don't know why, right? They have their reasonings. but that's what they're doing, is they're forcing you to use the public because you're going to have more than just application traffic. You're going to have management traffic as well. And so they're forcing you to simplify your setup as well.
Yeah, makes sense.
Yeah. Yeah. So, but ultimately the answer is, I don't know why they don't allow it. I just know they don't. So good. Any other questions? Sorry, before we.
Yeah, I have one question. Would you need multiple transit gateways for multiple regions? Say, for example, if you need a DR site and different region.
Let's see. Yeah, usually you want to set up transit gateways in multiple regions to do that routing. You can actually route to other regions, but the general recommendation is that you actually set up a transit gateway in each region that you're connecting to, like you're managing multiple endpoints to. Now, obviously, if you've got VPC peering and stuff like that, that can like bypass it, but typically it's a transit gateway per region. And you can actually have multiple transit gateways in the same region, like having some handling VPC traffic and some handling VPN and direct connect traffic, and have them like point together with each other. So it can get pretty layered with transit gateways, both within a region and in intra region or inter region.
Okay, thank you.
Yeah. I mean, you know, sorry, just to say this, there's just one thing that human beings are really good at. It's complicating things. So we can add more complication if we need to. But just to say this, I joke about it being complication. There are tremendously valid business cases for adding more transit gateways. So. Oh God, I haven't seen lags in a while, actually. They must have added this slide back in because I don't think it was here the last time I taught this class about a month ago. So you can use multiple connections for redundancy. So if you haven't used a link aggregation group before, man, we used to do this all the time. We would do it with modems and we would do it with ISDN and then later with DSL. And then, you know, I know that I'm kind of dating myself, but like we would actually get multiple connections and like aggregate them together because we'd end up with like fractionated like T1s, or one time I got to do it with a DS3, which is like 45 megabits a second. That was really fast back then. So anyway, you could create a logical a link aggregation group actually that allows you to kind of fold connections together, and it basically just looks like one pipe. Oh, the other place I used to do this was SANs. God, are we still touching SANs? People still have SANs? Anyway, so this allows you to aggregate like multiple dedicated connections to like a single like direct connect endpoint, and you treat them as a single managed connection. This is not AWS proprietary. This is pretty much a networking standard, right? Here, you've got 4 dedicated connections with 2 connections to each of the locations from the customer data center, right? So you've got 2 connections coming off each customer data center, and 2 are going to one direct connect location and 2 are going to another location. And what they do is that they're creating a lag, like an aggregation group basically for the connections that terminate in the same location. And so you then use the 2 lags, right, instead of 4 different connections. If there were 4 connections coming off the first customer data center and they were all terminating, you could link aggregate those together, right? And oddly enough, the link aggregation group actually uses the link aggregation control protocol. They actually named the protocol after what it does, right? Notice it says 4 links can be used. You can't use fractionated anymore. We used to use fractionated. Can't do it anymore. So you have to use actually either a standard 110 or 100 gigabit speed. They all have to be the same speed. So you can't mix like differing types together. Like you can't have like a 1, a 10, and a 100. That's not going to work. And of course, it does actually have to terminate on the same equipment because the customer gateway and the receiving like direct connect gateway, they have to manage all the connections at the same time. So all of those links have to terminate on the same gateway. If it's in different devices, it doesn't work. So, and then from there, you can then do your VLAN and your VIFs out to your VPCs. Just to check on something, am I breaking up for anybody? Because it keeps telling me my internet bandwidth is weird, which is interesting because I have nothing else running on the network. So, okay. Just wanted to check.
Yeah,
All right, so just know that you can aggregate links together. Let's see. This is a standard pattern that you probably saw for those of you who took the Solutions Architect Associates exam, where they talk about, hey, let's have a direct connect connection with a VPN failover. That's pretty standard. Notice it says 1 to 10 gigabits. It actually could be 100, right? Obviously, you're not going to get that speed off of your site-to-site VPN. So just let me just throw this little trivia question at you. By default, a single site-to-site VPN connection, what is the maximum speed you can run across that single site-to-site VPN connection?
Is the 1.25 Gbps?
That's right, but how many tunnels are inside of a standard site-to-site connection?
2.
Good. Just want to make sure everyone got that. There's 2. There's 2 tunnels inside of a site-to-site VPN connection. So remember that. So it's 1.25 times 2. So in case you missed that earlier, I know I said it several times, but it was like buried inside tons of other information. I just want to make sure that's clear. So if your internet bandwidth will support it, a single site-to-site connection could get you to 2.5 gigabits per second, not terabits. Don't follow the Michael Forrester post-coffee haze. Actually, I didn't even have coffee, it was tea. Remember, it's 1.25 gigabits per, and so you get 2 tunnels per site-to-site connection. If you want more speed out of your VPN connections and you want to run multiple site-to-site tunnels, you have to use a certain protocol in order to get that speed and that aggregation so they're used equally. What is the shorthand name for that protocol that will allow you to even out flow across multiple VPN site-to-site connections?
ECMP.
Yes, good. And for bonus points, what does that stand for?
Equal cost path
equal
routing.
plus multiple path.
Good. I heard you both saying it, right? So it's good. Yeah, equal cost multipath routing. Perfect. Okay. Notice, by the way, it says here, by the way, make sure direct connect is the preferred route so that it doesn't start routing, across both for whatever reason. Notice the VPN connection says a single one can be 1.25 gigabits, right? But notice there's 2 tunnels in there, right? So that means that there's going to be 2.5 gigabits of connectivity. The direct connect port speeds, I think, need to be updated because it's actually 1 to 100 gigabits. So that I know is wrong. So this slide needs to be updated. Okay, so that's just basically you doing a backup. You got a direct connect connection. Let's throw a VPN into the equation, right? Basic device resiliency. So ensure that resiliency to a connectivity due to a failure or fiber cut. Obviously, in this particular case, you can actually work that out with your partner. You can work that out on your data center, right? So in this case, what you would do is you would just duplicate your customer gateway. You would duplicate your direct connect locations, right? And just to say this, it's already redundant on AWS's side. So even though it looks like you're going into a single point, you actually would end up being redundant. Let's see, this is high resiliency. So notice here, we got a single direct connect location, but now we're worried about DR, right? So then you got multiple locations. So this also will save you from like single building fiber cuts, right? So notice we've got now multiple buildings involved. Notice that AWS is not showing you multiple connections from their partners back. I know this is going to sound weird, but Amazon's not running cables every time you run a cable. That probably makes sense to you, right? Their connectivity to their partners is typically going to be, actually going to be terabits. So this is not me just not being awake, right? It actually is going to be terabits. So you're going to get whatever slice of that terabit you need in order to run, but they're not going to give you a dedicated cable, right? So they're running massive bandwidth across between their partners and them. I did have one client who actually wanted Amazon to run their own dedicated cable because they didn't want to be on shared. That was a long time ago, like 4 or 5 years ago, and they did actually do it. So they had to pay for it. It was expensive, relatively. Maximum resiliency, although this also looks like maximum insanity, is basically running, obviously duals in both physical locations. I guess, that is actually a maximum redundancy. So just know that's also an option. All right, so we talked about client VPN. We did site to site. We just covered direct connect. Let's talk about the Route 53 resolver. Any questions about anything we've talked about this far? Okay. Actually, hold on just one second. Slide 43. All right. No, good. Okay, let's talk about Route 53. Okay, so here what we're trying to do is we're trying to resolve, right? Trying to use private zones in Route 53, which is the DNS service. We're trying to basically allow on-premise people to resolve to AWS resources, okay? So as you probably know, if you've ever dealt with DNS, right? Private hosted zones, right? Contain basically records about how you want to route traffic inside of VPC, right? So this is used to access resources in your VPC using, custom domain names. So obviously you can link a zone to more than one VPC, right? Just depends. And you're going to create the standard A or quadruple A records. And then it's by default, you're not going to be able to resolve from on-premise in, right? So, yeah. Notice also, by the way, if you have a shared services VPC and you've got like VPC endpoints, right? You just either need to add some kind of layer 3 connectivity between a VPC and its destination, right? So you can either use VPC peering, you can use a transit gateway, or you can use a VPN. Notice I didn't say a direct connect gateway with a private VIF, right? So this is where the architecture becomes a little bit more complex, right? So what happens is that when you create a VPC endpoint, right, to an AWS service, so let's say you connect it to S3 or you connect it to, Fleet Systems Manager or whatever, you can actually enable private DNS. When this is enabled, what happens is that it's going to create an AWS managed private hosted zone for you. So this is going to allow you to resolve to the endpoint, right? The VPC endpoint with a DNS name, but it's not going to work outside the VPC, right? So this is where you're going to actually have to look at like doing some private host zone sharing and using the Route 53 resolver come into play to get you unified name resolution for these VPC endpoints and other resources, particularly in your like corporate networks. So this is really what private hosted zone sharing and the Route 53 resolver is trying to solve, is it's trying to get it so that your on-premise resources can solve the resolution to VPC resources. So this is hybrid resolution. So you get an on-premise DNS server. Okay. So interesting thing here is that to share a VPC endpoint with other VPCs, right? We talked about like you're going to need like either transit gateway or VPN or some variation thereof, right? So if the VPC resides in different accounts, right, you can actually share what they call your private hosted zones. You can actually share your private hosted zones, right, in other accounts. After the sharing sets up, then these VPCs are actually going to resolve actually to these service names. Now here, you notice that the client is resolving to an on-premise server, which is then hooked in, right, to some kind of like the Route 53 resolver, right? So some kind of DNS exposed service, which in this case is the Route 53 resolver. And so it's going to resolve in to the VPC, into the DNS that's there. And then it's going to route either to the inbound endpoint, the outbound endpoint, and then it's going to actually match the various rules that you have set up, right? So you can actually set up Route 53, what they call resolver endpoints, to actually forward your DNS queries from your private to these endpoints, and they will actually resolve based on the rules that you've set up. Now, these forwarding rules or resolution rules or matching it to a private hosted zone, that level of like resolution is going to be determined by your particular use case, right? So when you create this inbound, Route 53 resolver endpoint, which is a really horrible name, because that's the official name for this. This is a Route 53 resolver endpoint, right? That's what you're going to be like targeting your DNS server to forward its request for AWS to, right? So you're basically linking your on-premise DNS server into AWS's DNS server, and you're creating some rules about how you want things to route. Does it sound complicated? When has DNS ever been simple, actually? So you shouldn't expect it to ever be simple, right? Notice here, traffic is being forwarded in, it's forwarding over to the resolver, which is then getting routed either to the inbound endpoint. And so what happens is it's going to go into the inbound endpoint through basically the shared services like the spoke VPC. and then it's going to hit a hosted zone, right? If it's coming from the other direction, what's going to happen is it's going to have forwarding rules on the other side that says, you know what, you're looking for something that actually exists on the corporate network. And so I want you to go outbound, hit this interface, resolve back to the on-premise DNS server, and then get to the resource in question, right? So notice that one is resolving from client from blue on-premise to customer. The one in red is going from the EC2 instance, which is in the lower left-hand side, all the way back to the on-premise DNS server, which is then going to point to those on-premise resources. Just to say this, the connectivity between the on-premise DNS server and that Route 53 resolver endpoint could be VPN, could be direct connect, right? In other words, it doesn't necessarily, it's not like you have to publicly expose your device. You can just do it privately, which is what most people do, actually. So this is with private zones. This one, let's see, is a little different, right? Because we're resolving in, we're matching a particular rule to a hosted zone. Oh, and what's interesting is that the resolver is actually in not the primary kind of like services account. What's happening is that your EC2 resources are actually in like one, basically a spoke account. You know how we have hub and spoke, right? So the hub account is the one that contains all of the rules. And what's happening is that this Route 53 resolver endpoint, which notice how it says .2. .2 is typically the IP address that Amazon takes off of your subnet in order to like have DNS resolution, right? And so notice here the EC2 instance, which actually I guess I could annotate this to make it a little easier. This EC2 instance down here, when it goes to resolve this, has a rule that says, hey, you know what? You need to actually go this way in order to get to this server to resolve this like some unnamed resource that we're looking for. Again, it's going to route through this VPN or direct connect connection. The main thing you need to know is that you're going to set up your Route 53 resolver endpoint, right? And set that up on every single VPC where you want it to route back to your corporate network. Now, all it needs to do, by the way, is point to this outbound endpoint in order to resolve. You can actually set up all of your forwarding rules here. And then those forwarding rules will tell you exactly how it's going to forward items back to the DNS server. You can throw a transit gateway in here, obviously, to centralize traffic. So just remember that these inbound endpoints and outbound endpoints, see this little symbol right here? What are these? Someone tell me what these are on your network. What does that symbol stand for?
A NIC?
That's right. They're just like interface endpoints or gateway endpoints. Well, not gateway endpoints, interface endpoints. It's a NIC, right? So you can actually point towards specific IP addresses for resolution. So think of the Route 53 resolver endpoints as being a way for you to capture and point towards DNS resolution, either inbound coming from your on-premise network into VPCs or outbound coming from one of your like subnet VPC networks out back to your on-premise resources, right? So remember, the inbound is the one that goes from on-premise to AWS. The outbound goes from AWS back to your on-premise resources. You can throw all kinds of things in here. Transit gateway, direct connect, VPN. You can run over public if you want to. I would recommend that. And remember that in each of the different spoke accounts, in each of the VPCs, you can actually set another Route 53 kind of resolver, which by the way is there by default. You can just, and by the way, all these EC2 instances point to it by default, right? So once you turn on a resolver endpoint, it shows up in your account as an option that you can now like point to, okay? Let's see. The other thing to say was that if you want to share If you want to share your inbound and outbound resolver points with other accounts, you can also use the AWS Resource Access Manager, which is relatively new. Okay. Questions?
So a lot of these networking concepts terms are fairly new to me. Recommendations for getting more understanding.
Yeah, so my recommendation is actually go like peruse, for example, the AWS documentation. I know that sounds strange, but the documentation is actually remarkably well written. So
Yep.
for example, just to facilitate that, that name always throws me. So for example, this is the Route 53 resolver endpoints, right, between VPCs and networks. So you can find like information here. It is simple to read, very well done. Usually has examples on configuration and, you know, obviously some really great network diagrams, right? So just know that like, this is actually where I would start, is I would just like, because it does assume that you understand how DNS resolution works inside of AWS. And so if you're missing any of the fundamentals, this will fill in the gaps, right?
Yeah, cool.
Yeah, I'll paste this in chat, just make it easy. One of the few times, by the way, I will ever point you to the documentation, like directly, is around the networking stuff. So that being the technical term, the networking stuff. Okay. All right, so here we go. I feel like this one's going to be a softball. What is not a valid connection point for a site-to-site VPN to AWS? Yeah. Remember that very first diagram that we looked at, right? Virtual gateway, EC2, transit gateway. So load balancer definitely is not going to be site-to-site VPN termination point. Good. What is not a valid termination point for a direct connect link? Oh, this one actually would be pretty hard, except that there's a huge gap in one of the answers. So, by the way, what does a transit VIF actually go to? Transit GIF, right, is to a transit gateway, right?
Yeah.
So just to say this is that B is the one that's like off. Oddly enough, you can actually terminate a private VIF if you want to onto a VPN connection, right? You can actually terminate it into a VPN interface if you want to, right? Because VPN does support, remember, VPN is supported against, right, EC2 based connections, transit gateway connections, and we literally just answered that question, right? It was this one. So literally we could actually terminate VPN against an Amazon EC2 instance. So then why couldn't you actually terminate a VIF against VPN, especially if it's running, right, a VPN connection? Remember, as long as it's IPsec, it'll be supported from a VIF. So just remember the transit VIF though goes to transit gateway. Okay. Using a direct connect private VIF, you can connect to 2 VPCs in any region. Yeah, this is true. This is false, right? Why? Because if you want to connect in a region, you're going to need probably a transit gateway, right? That's why the transit VIF is there, right? Private VIFs are really for private resources inside a single VPC typically. Now, if you're peered up, you can obviously get to them, but you know what I mean? If you want to get into other regions, the VPCs in any region, you're going to need to connect to a transit gateway. All right, you can connect to AWS client VPN using the AWS provided client or any open VPN based client. Remember I said there was a AWS VPN for desktop, right? And what else? Now, oddly enough, this is true actually. As long as it is an open VPN based client, because that's what they're using on the back end with IPsec, it actually will work great. So this is a true statement. Now, if you're trying to connect GRE instead of using IPsec, that's not going to work. But any open VPN based client, because the AWS provided client, by the way, is just a reskin of an open VPN. I think I said that earlier. Okay. Question 5. What is not a default use case for private hosted zones in Route 53? Let's see, route traffic in a VPC using custom domain names. I think we talked about that one, so that makes a lot of sense. Create single A or quadruple A records, quad A records. I think we very clearly said actually that you could do that. So that's definitely true, right? Link a private hosted zone to multiple VPCs. I very clearly said that as well. But let me tell you, just saw it one time, so it's not like I expect you to memorize that right off the bat, right? Resolving private zone records from on-premise. Resolving private hosted zones from on-premise, right? That's not going to happen. How do we resolve private hosted zones that are on somebody else's premise? How do we do that? Amazon's not going to do that. Who's going to do that? If you want to look up a resource that's inside your corporate network, where are you going to go for name resolution? You're going to go to resolver part, so you're dead on, but whose resolver are you going to go to?
The on-premise, right?
That's right. Say if you're going to go to the on-premise one, because that's Amazon's not, unless you want to set up some kind of replication, Amazon's not going to you're going to use internal DNS, right? They're not going to try and resolve that. They're going to forward you to the authority for that, which is going to be your on-premise DNS server, right? So just know they're not going to resolve your private zone records from on-premise. They're going to forward you over. Okay. Did that feel humbling? It's always humbling whenever I do this. It's humbling for me, right? Because it's a reminder of like all the stuff that I've forgotten actually, as far as ASNs and BGPs and, setting up like deep networking. Because I don't, honestly, cloud has taken that away from us to a certain degree, which is awesome. Although I have to say, I still meet network engineers on a regular basis who really do some deep networking on AWS. But since this isn't the network engineering exam, we're not going to go down that road, right? Yeah. Good times. Okay. So reminder that we just covered client VPN, site-to-site VPN, direct connect, and we just talked about basically domain name resolution inside of AWS. Okay. Let's talk next. Actually, you know what we're going to do since we're so close is that we're actually going to take a short break. So let's take a break actually first. So since it's about 10:45, let's go ahead and take a 15-minute break before we roll into the next section, because it's also going to be pretty sizable. So it's 10:44 by my clock right now. I'll put up a timer. Why don't everybody come back at 11 and, grab whatever you need. Okay. We'll see you in a bit. All right, here we are. I know we just did some kind of external networking. We're going to do a little bit more networking, but this time we're actually going to talk about Transit Gateway, which is kind of an interesting order of events for this class, because I feel like maybe we should have started there, honestly. But okay, regardless of me not being emperor for a day, let's talk. We're going to talk about Resource Gateway. We're going to talk about Transit Gateway. We're going to talk about the Resource Access Manager, and we'll talk about one other thing, which I actually can't remember off the top of my head, but we'll get there. First question is first. How many VPCs does your organization manage? May know. Let's see. Most organizations I know, oddly enough, focus more on multi-account than they do on multi-VPC. But they still end up with somewhere like multiple VPCs per account. So it still ends up being hundreds of VPCs in general, usually. About 11.99. Okay, good. All right, so then here is kind of a trivia question. Which statements are true regarding VPC peering? Ah, that's probably the other thing we're gonna at least touch on, right? So peering connections are definitely one-to-one relationships between VPCs. So that's definitely dead on. Well, let me ask you this. If I hook VPC A to VPC B, and I hook VPC B to VPC C, does that mean that A and C can talk to each other? Because that's what transitive means, right? Yeah, Amazon has a very staunch policy that they do not support transitive peering. So you can't run through another connected VPC to get to another connected VPC. So B is definitely not it. You can only peer VPCs in the same region. That actually used to be true, right? But it changed a while back. So you can actually you can connect VPCs in like Tokyo and, Virginia if you want to. Even though it's going over a high-speed backbone, I suspect there'll be a little bit more latency. That's just my hallucination. Maybe I'm wrong. But D is definitely true, right? You can actually peer VPCs from different accounts as well. So A and D are the answers. Now here's another trivia question. How many connections are required from a customer gateway device for an on-premise VPN to connect directly to 6 VPCs? If there's 6 VPCs that you want to talk to directly, how many VPN connections do you need? Yeah, so that's correct. So I have 6, right? 1 for each of the VPCs. If you want to talk directly to the VPC, notice that was the qualifier, right? If you want to connect directly to it, right, you're gonna have 6 connections. Does that mean you can't do it differently? No, you can do it differently. You could connect to a transit gateway. Anyway, we're gonna talk about all that, but if you want to connect directly to it, you're gonna have 6 connections. Let's see. Am I gonna start the lab? Oh yeah, no, I am starting the lab actually. Let me just go ahead and get that started just to make sure. I'm gonna pre-warn the labs for lab 2, which is gonna be the transit gateway. I keep thinking that we're gonna take off for lunch, but we don't have time for that, do we? No, forgot we're on a sprint, not a marathon. All right, so we're gonna be connecting some networks. Obviously, we're gonna be doing a lab directly after this. We are gonna be, during that lab, if you finish early, you're gonna take a break if you want to. I think the lab's time, actually, I think I already had that slotted, didn't I? We're gonna be spending about 60 minutes doing that lab. Maybe less, maybe 45. First, let's talk about this. So we're gonna talk about Transit Gateway, the Resource Access Manager. We are gonna talk about Private Link. Private Link is nothing more than you creating your own personal interface endpoints. Meaning you can actually create a published interface endpoint that you then allow someone else to consume, even in another account, which means they don't have to go across the internet. Obviously, this is all AWS, right? So if you have a customer in another account and you want to share a service that you've made with them that's behind a load balancer, you can create your own custom private link interface endpoint and then share that with the customer, and the customer can hook into it. It's all permission space, by the way. So like when they try to hook into your service, it's going to say, hey, do you want to let them hook into your service? And of course you say yes, right? So we're going to talk about these like particular pieces. Here's the cool thing is that we're going to be like in this particular project scenario, we're going to be sharing data sets between applications across a bunch of different customers. So we're going to have to like be able to research solutions and discuss with security about, I guess, how to share data sets between applications. The user stories that we're focused on is, can we reduce the number of peering and VPN connections? What options are there other than VPC peering? We have internal SaaS applications that needs to share with multiple VPCs. We also have VPCs owned by different accounts. Right now, only the account owner of a transit gateway can attach VPCs. How can we shift this? So let's get into it. We're going to talk about transit gateway. We're going to talk about the resource access manager, which I referred to earlier. We're going to talk about creating your own private interface endpoints, your own private like NIC service endpoints called private link. Let's talk about transit gateway. All right, this one is basically transit gateway is used to simplify the number of VPN and peering, like VPC peering connections that you have. All right, so here's the deal. Without transit gateway, the connection from on-premise to a VPC is a one-to-one relationship. So if you've got 6 of these, right, you're going to have 15 VPC peering connections. I feel like there's one missing there. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Where's the 13, 14, and 15? Oh, they don't have the other 2 devs and prods connected together. So actually there's a couple of lines missing off this diagram. Interesting enough. Anyway, so look here. So this is not atypical. We've got 6 VPN connections because we got 6 VPCs, right? So that would be this item down at the bottom. We got 6 VPN connections, right? Because we got, you know, right, 6 VPCs we're talking to. We've got 12 physical tunnels, right? Interesting. We got 6 VIFs, 12 if we're going to do redundancy. So we got virtual interfaces for each of these as well. Notice that all of this is like a multiple of 6, right? We got 6 VPCs. Now the 15 VPC peering connections, that math has always thrown me out. I know it's right, but like if you've got 6 VPCs that are all connected to each other, it generates like 15 connections, but I can't remember exactly how, but it's like you have each VPC is talking to 5 other connections, right? But obviously there's some redundancy there, but it ends up 15 independent peering connections. So this all has to be managed individually, by the way. These are all independently governed. They each show up as a connection, an independent connection, independent routing table, independent VPC peering connection, right, inside your setup. Now, if you throw transit VPC in here, sorry, if you throw a transit VPC, transit gateway in here, what ends up happening is if you have a transit VPC, right, which basically allows you to centralize traffic to like a network configuration, it's basically just a VPC. This is not transit gateway, by the way. This is basically a VPC that just runs routing software. Typically, that routing software is going to be on an EC2 instance. Why? Because Amazon doesn't allow you to route by default, right? It's not going to let you use a service for this. You're going to have to do it inside of a box of some type. So this could allow you to connect everything to this transit VPC, and now everything's going to like go through this VPC, right? So it's a common VPC that serves as a global network transit center. Now security loves this. Why does security love it when everything is centralized into a transit VPC? What does that make easier?
They'll put like traffic monitoring on it.
That's right. Deep packet inspection, traffic monitoring, filtering, capture, the whole 9 yards, right? The problem with doing this is its complexity and the level of skill required. First of all, you're going to have to know iOS or some other networking vendor, right? You're going to have some complex segmentation lists as far as like routing what to what. You're going to pay for the EC2 instance. You're going to pay for the licensing of the third-party software. And the scalability of the solution is limited by the cluster capability and the hardware selected for the transit VPC by the vendor in question. I'm not saying that those are horrible issues. You can do that, right? But Amazon wants you to use a managed service. Remember, they're trying to democratize operations. So this is the kind of thing that they want to create a service for, so people don't have to do this. Well, then this simplifies to this. Now, this is a little bit disingenuous because there are still lines pointing, back just like this. Don't be fooled. It's like those pictures where the person's like sucking in their gut, because it's like they lost 10 pounds and they weren't doing that on the other picture, right? And the lighting is all bad. Just so you know, this still looks somewhat like this with Transit Gateway, but the distinction is that this is now obviously fully managed by AWS, and its job is just to act as a cloud router that's part of your network architecture. Now, notice this is not a VPC, so it sticks hooks in all of your VPCs and basically allows you to route traffic to and from the VPC in question through those hooks, which is generally just a NIC, right? By the way, this also has, does it actually say this on the, no, it doesn't say this. It also has there's a Transit Gateway Network Manager, which it will allow you to easily monitor your VPCs and your edge connections from a central console, right? So there's a network manager. I think there's a picture of it, if I remember correctly, in the slide deck. But the Transit Gateway Network Manager helps you quickly identify issues with your connected devices to the Transit Gateway. So traffic that goes between these VPCs, by the way, remains on AWS's global private network. It's not exposed to the internet, right? And you can actually use what's called Transit Gateway intra-region peering, which is going to encrypt all your traffic, and there's no single point of failure. So this is going to protect also against distributed denial of service attacks and other common exploits. It does support multicast. So if you want to go to multiple destinations, you can do that. So this is going to eliminate the need for like multicast on-premise networks or bandwidth need for things like video conferencing, media, teleconferencing, right? So it scales elastically based on the volume of traffic. So think of this as a load balancer. Load balancers scale invisibly underneath the load balancer endpoint. You actually don't know the number of devices. This is not a single point of failure. Okay. So this is just a cloud router. It does support IGMP as well, which is the Internet Group Management Protocol, as well as IP multicast, which I just talked about. So it basically acts as a router for all of your traffic. Now they are regional, by the way. So they are typically regional. You can use them for inter-region peering and routing, and you can run multiple transit gateways in a single region. So we're gonna talk more about that. Here are the components of a transit gateway. One, you should know already that like VPCs obviously have route tables and subnets, and there's virtual private gateways, and there's direct connect gateways, right? So let's learn a little about the ones on the right hand side. Basically the transit gateway route tables and the transit gateway itself. Okay. So transit gateway is a regional resource. You can have more than one, right? So it acts as a virtual router. You can peer transit gateways, by the way, across regions, but remember, it's going to be region specific. It's a managed service. So what happens is that you attach the resources that you want to route to, you attach them to a transit gateway. So you can attach a VPC, you can attach a VPN connection, you can attach a direct connect gateway, and in the same region, and you can route traffic to them. Now, a transit gateway will work across AWS accounts, and you can use later on when we're talking about the resource access manager to share your transit gateway with other accounts that you own, right? After you share a transit gateway with another AWS account, the account owner of that account can attach their VPCs to your transit gateway. Now, remember, if you're in an organization, you need to grant access to the resource access manager, right? Because remember, if you're in an organization, someone's got to explicitly allow that. The transit gateway attachment, when you attach like a VPC to the transit gateway, it is both a source, the attachment can be a source of packets coming into a network. It can also be a destination of packets leaving a network. So VPCs, VPN connections, direct connect, and transit gateways are all things that you can attach to a transit gateway. if you're going to peer a transit gateway with another transit gateway, just be aware that that is reserved for transit gateways that are in different regions, right? So you're not going to link them together if they're in the same region, although you can route with different transit gateways that are transit gateways that are in the same region, but you can't peer them together.
What's
Transit
the difference between those two, between the routing and the peering?
Routing basically is they're not connected. They're just sending traffic to each other. And so they're routing independently. With peering, you've actually got it directly connected. And so it's actually just route, like in a sense, it's routing from one region to the next. Because if
So-
you peer, you're already going to another region.
So peering would basically, it's the same as routing, but it technically means in this case, going to a different region.
Yeah, it's inter-region versus intra-region.
Yeah.
Routing would just be inter would be
Okay.
obviously inter. So transit gateway is going to support dynamic and static routing attachments between like the systems in question. And you get to control route propagation. So if you want to publish routes, you get to control how those routes are propagated, including coming from the sources, the attachments that you've added. So if you like don't want someone to advertise their route, you can control that if you want to. Here is a direct connect routing to a transit gateway. So by the way, what kind of virtual interface do you use? Remember, we just asked a question about this, right? It's not a public, it's not a private. What kind of virtual interface do you use to hook into a transit gateway? It's a transit VIF, right? Don't forget, there's a public VIF, there's private VIFs, then there's transit VIFs. Transit VIFs are the ones that you use to correct, for example, like a direct connect gateway into a transit gateway, right? You gotta use a transit VIF for that. Okay, if you do decide to take your DX gateway, your little direct connect gateway, instead of running it directly to VPCs, right? If you want to actually route to multiple VPCs or VPN connections or other connectivity and just add a lot more flexibility, you can actually just route that DX gateway through a transit VIF to the transit gateway. And you will say, well, Michael, why would I do that? One, it's going to be easier network management. Two, you can actually advertise prefixes, like you can propagate routes if you want from on-premise to AWS and from AWS to on-premise. So routing becomes a lot easier at that point in time. And then it basically allows you to manage a single connection for multiple VPCs or multiple VPNs that are in the same region. Otherwise, you have to manage each of them individually, right, from the DX router, from the DX gateway. So it really simplifies this network management. It's mainly what it does. Wait, did I miss that? Oh yeah, no, it's just inserting it a little out of order. All right, so you already know, by the way, that VPCs use route tables to that are attached to subnets to control traffic. Subnets obviously can have their own individual route tables, or they can inherit from the VPC, right? So when you take a transit gateway and you attach it to a VPC, you've got to enable one of more of the availability zones, the subnets inside the VPC, to be used by the transit gateway to route traffic to resources in the respective subnets. So to enable each availability zone, you just specify the subnet in question. The transit gateway, oddly enough, is going to take a virtual NIC. It's going to take an ENI, basically. It's going to stick it inside the subnet. And it's going to take an IP address from that subnet. Make sure you heard that. Transit gateway is going to stick a NIC inside every subnet that you want it to talk to, and it's going to take an IP address off that subnet. So then, after you enable an AZ, for example, traffic can be routed to all the subnets into that availability zone, not just that specified subnet, right? I know that sounds strange, but basically once you stick a network card in one of the subnets in the availability zone, it's going to be able to talk to all of the subnets, not just the specified subnet. So basically any resources that reside in that data center where it's actually put a NIC inside one of the subnets, right? It's going to be able to basically talk to the transit gateway. So just to say this, if you do not enable the transit gateway to stick a NIC inside the availability zone in question, let's say you're in Virginia and you decide you don't want to stick one in E, none of the resources that reside in that availability zone will be able to talk to the transit gateway. So you have to have at least one subnet with a NIC in it inside the AZ in question. Now, of course, Amazon's going to tell you, just make sure that you enable basically multiple availability zones. Even if you like aren't going to off the bat, like talk to that AZ, just go ahead and do it. Just make it even, right? In the VPC route table, by the way, when you attach a VPC to a transit gateway, you've got to add a route to your subnet route table for traffic to route through the transit gateway, right? So just know it's now going to like push to the transit gateway. It becomes an identifier, by the way. So we basically say, look, and notice here they're using a default route to route everything to the transit gateway. Obviously, you're going to do what's appropriate for your network configuration. You don't have to send everything to the transit gateway unless you really want to. Let's see. Regional virtual routers, that's not a surprise, operates at layer 3 with packets sent to the next hop. Targets for routes are defined. Okay, so this is what happens. So if you decide to use the transit gateway as your router for all things, which you can do actually, you can just use the transit gateway as a router for all things, which by the way means that transit gateway will actually send to the internet gateway if it doesn't have any matching routes if you set it up to do that. So it's not like you have to rely just on the VPC's routing tables or the internet gateway through the VPC to route. You can actually just hit transit gateway and it will actually be able to send traffic to the internet gateway if you want to, right? So notice that then if you decide to route all of your traffic through the transit gateway, this is now going to allow you to create custom routes inside the transit gateway's route tables, right? That you can then associate with whatever direction, path, or traffic you want. So for example, if you need to send traffic coming from a VPC to a whole set of VPN IP addresses, you can. If you need to send them to a bunch of direct connect IP addresses, you can. In other words, this now gives you a centralized place, no matter where the traffic is coming from, to route to other places and control it in one central place. So instead of having to manage now the route table between the VPCs, the VPN connections, and the direct connect gateway, they're all sending all of their traffic over to the transit gateway. So just manage it in the transit gateway, right? If they're already going to all send their traffic over there anyway, you can just do all your routing there and let the transit gateway handle where things go. This is the great power of a transit gateway, because now you're not in 3 different places in the console having to manage all this. Once you've set the transit gateway as your default router, let transit gateway handle everything. Now, obviously there's going to be edge cases where that doesn't work, but for the most part, it works really well. Each attachment, by the way, so here we've got VPCs associated with a single transit gateway route table. So you can actually, like by default, transit gateway creates a default route table. Why? Because everything in AWS creates a default route table, right? When you start a VPC, it's got a default route table. Transit gateway does the same thing. You can associate a transit gateway attachment, which in this case is either a VPC, a VPN, or a direct connect connection with a single route table. Each route table, by the way, can have multiple network attachments and forward packets to other attachments, or you can create separate route tables for them if you want to, for whatever reason, if you want to do that. This is going to do IPv4 and IPv6 using these gateway route tables, and you can use the route tables to propagate routes from the route tables that are actually in the attached like VPCs or the VPN connections, right? You can also add static routes if you want to the route table to manually define it instead of inheriting from the VPC. Just make sure that's super clear. This VPC already has some subnetworks on it, right? Like it has a network. It says like, let's say it's 10.1. So it's already advertising that it controls the 10.1 networks. Let's say this one's got 10.2 networks and this one's got 10.3 networks. You can actually set transit gateway to just accept those advertisements, or you can statically define them. That's what I was saying earlier. Is if the VPC is declaring that it owns this network and that's what it's advertising, you can just let transit gateway accept that. If you want more control over it, you can statically define it, right? Obviously, you can share the same route table with multiple VPCs, or you can create your own separate route tables. That's up to you. Now, that's using route tables. The default, by the way, so if a shared route table is configured to allow it, transit route, like VPCs can actually route traffic to each other just like they're paired together. So you can actually, because if you allow the route table to just accept those advertisements, you can let's just allow these VPCs to talk to each other, and you don't have to create a VPC mesh. You don't have to create a VPC peering. You can say, look, route table, if a VPC comes online and I attach it to my transit gateway, if somebody's looking for that VPC, then just send them to it, right? If they're looking for a 10.1 network, then just send them to it. Now, guess what you're doing? You're not maintaining a VPC peering connection and maintaining the routing tables in each VPC. You're just maintaining this single route table. That's it. So this simplifies administration and security. So a lot more simple.
Quick question there. So are you saying that if I have 10 VPCs, all of them goes to the transit gateway, right? And I manage traffic. So that means I can manage the internet gateway traffic of the VPC from there as well.
Right. Well, because by default, it's going to send it to the transit gateway, right?
Yeah, and then I decide like which of the ones has an internet connectivity, which doesn't.
Right, exactly. You can say, look, for you, I'm not going to accept traffic. For the others, I am going to accept traffic. Like I'm going to default route you out, right? So you can control who gets access to the internet and who doesn't. Typically in that setup, just to say this, it actually typically is, I usually create separate route tables for that, just to make sure I don't cross the streams. So you just CIF just to make sure, right? Because sometimes that can get confusing. The reason I do that is that I once had somebody come in and add a default route table and then propagate it out to all the VPCs. So usually what I do is I create a separate route table for the private VPCs and one for the ones that are public, right? That have public subnets in them, just to control that access a little bit better.
Yeah.
Remember, by the way, that can actually still be done also at the subnet level. Remember, you can actually still go into the subnet and set a custom route table that doesn't use the VPC route table. And so it could completely ignore using transit gateway, and you could control it that way as well. So just know that just because the VPC is set that way doesn't mean the subnet has to follow that. Remember that route tables can exist at a VPC level, but each individual subnet inside the VPC can have its own custom route table if you so choose. So there's a lot of granularity for that. Okay. Now, in this case, by the way, this is almost exactly what I was just talking about, which is completely unintentional, right? Where you've got like a second route table that has maybe a different kind of like access to the internet gateway, as an example, for this particular VPC and maybe other VPCs like it. So. All right, so you can actually modify the transit gateway table associated with, for example, with VCVC 1 and 2 to specify that if the traffic is non-local, maybe it should be forwarded to VPC 3. So again, this just highlights that you can create all kinds of custom virtualized routing solutions with the transit gateway. Remember, that's all this is. It's just a router, right? So so any CIDR like network range that the VPC controls, you can actually just set it to advertise, right? Now, in this particular case, the way they have it set up is that VPC 3 could be centralized as the outbound perimeter point for the internet or access to some other shared service, right? It doesn't really matter. Ooh, can you hold this 1 second? And I gotta tell you, that's a disconcerting feeling. All of a sudden, I smelled gas in the house. Wow, between a busted water pipe and a gas, I'm either just trying to burn it down or flood it. So anyway,
And that's now on the record.
Yeah, exactly. Now you're all witnesses for the prosecution, so we'll just move on from there. Bottom line here is that if you still want like a centralized, outbound kind of VPC, you could actually set that up as well, right? Do note, by the way, the transit gateway will actually force traffic out through a VPC to get to an internet gateway. So it can talk to the internet gateway directly, but it can also force it out through a VPC to get out. Again, note that this could actually be a private link endpoint too. Like you could have a private link service that offers, like, for example, Databricks, like if you're doing EMR, like MapReduce or Spark or Apache Hive, you could have like some kind of service like that, or Snowflake. I've seen, God, what was another company that offered services? Oh, OpenShift. OpenShift would offer services through a private link endpoint, and you would actually route to their VPC. So there's a couple of options for that. Bottom line, Transit Gateway is an incredibly powerful routing like solution. So you can create all kinds of custom configurations. Just remember that the route propagation piece is actually also incredibly powerful because it just allows those route tables to get populated with the advertisements without you having to do a lot of configuration. That might seem like a nightmare for security, but if it's already an approved VPC, then you don't care if it propagates its route, right?
Can you set up the transit gateway as infrastructure as code? Or is it all
Yes.
console based?
Oh yeah, no. AWS is API driven, so yeah. The transit gateway at this point is old enough to where it's actually in CloudFormation, but it only takes CloudFormation, the CloudFormation team, like maybe a couple weeks to maybe a month or two sometimes to get features into the CloudFormation setup. So you can actually set up transit gateway all through CloudFormation. Now that requires a lot more orchestration, Brad, just so you know, because you got to go find the IDs of all the stuff you're trying to attach. So I wish it was just like a command line. It's like a single command line to attach like a VPC or a VPN to the transit gateway, but you got to go find it. You got to go find the ID of the VPN or the VPC. And so you got to like make sure everything's tagged correctly. And then you got to anyway, you get it, right? So
yeah,
you got to go find it programmatically. Some people have done, by the way, for that, Brett, just to mention this, is that they'll put tags into all of their VPCs and VPNs that says transit gateway enabled, yes or no. And what it will do is it will go and parse all the tags for all the network resources. And if it says yes, it will automatically add it to the transit gateway in question. So you have to come up with a kind of a labeling strategy, like a tagging strategy, to programmatically pull that off without having to manually go in and find every single VPN and VPC resource. So. Okay, so here we switched from intra within a region, right? Now we're doing inter, right? Which means we're going to peer two transit gateways together and we're going to route traffic between them. So here, what all you're going to do is that it's just another attachment. It's a peering attachment, but you're basically going to like create a peering attachment between your transit gateways, and you're just going to specify another transit gateway in another region. The peered transit gateway, by the way, doesn't have to be in your account. It can be in a different AWS account. Just so we're clear, the owner of the account that you are requesting to peer with has to accept the request. This is all like consensual, right? So to route traffic between the transit gateways, just add a static route, by the way, that points to the peering attachment. Because what's going to happen is you're going to get a peering attachment that you can then refer to in your host tables. So notice that this does not support resolving public IPv4 DNS host names to private addresses across the VPCs. So it won't resolve publics to privates. Amazon does a lot of that for you, by the way. When you request a public IP address for an EC2 instance that's in your account, it'll automatically convert it to private and just run you over to it. It won't do that across the peer connection with Transit Gateway. So these connections are encrypted. So just know that just like VPC peering, they are encrypted by default when you peer these things together. That's another difference, by the way, Brad, from what you were asking earlier, is that the intra can, if you're just routing between two transit gateways, that traffic's not encrypted. Okay. Here's a couple of use cases, right? here, transit gateway is acting as a centralized router. Customer gateway is coming in, right? For like all your like, VPN, client VPN connections, all the attachments associated with the transit gateway. So in this case, all the VPCs and all the site-to-site VPN are going to like run off the route tables they're associated with. And so they can just route packets to each other, right? So this, in this case, it's just acting as the layer 3 router. That's it. Notice, by the way, on the back end that these VPCs can all talk to each other, right? Right? You could isolate one of the VPCs off. Again, this is all just routing, so you get to control this however you see fit, right? In this use case, we've got a shared services VPC that everybody else can talk to, but they can't talk to each other. Another use case. Oh, here we've got a peering connection between gateways across different regions, right? Because maybe what's happening, and by the way, this happens a lot, is that your VPN, your site to site is actually going to a particular region, but you need to talk to VPCs in another region. You could do VPC peering. Don't get me wrong, still do that. But what if you got a bunch of these, right? Just hook your transit gateways together, and then any VPCs are launched, by the way, you can set it to just automatically show up in your routing table. Otherwise, every time someone launches a new VPC, you're going to have to add that into VPC peering and do some configuration to get that to function. If you're using a transit gateway, it's just going to show up. Here, they're actually using a NAT gateway as a shared service. Let's take a look at this one. This one's interesting. Okay, so we've got a transit router. So let's do some highlighting here. So we've got a transit router. So we got our default route going to the transit gateway. So we're here in a VPC, it's talking transit gateway. We're on the gateway. And it's basically saying, look, I need you to go to the outbound VPC for this traffic. Oh, and by the way, there's some black hole traffic, which means that just gets like trapped, right? That just dies. This just goes into a black hole. That's another thing where you can just capture traffic. All right, so the VPC, this one is sending non-local traffic. Actually, that's a lot of drawings. Let's try that again. So this one's actually sending non-local traffic, right, to the transit gateway. This black hole route, as mentioned before, ensures that VPC A and VPC B cannot talk to each other. So this makes sure, by the way, this particular route right here, make sure that these guys cannot talk to each other. Why? Because this is 10.2, this is 10.1. When this guy comes here to try and route to talk to 10.1, it's going to hit a black hole and get eaten. In other words, it's not going to make it over here because this black hole is going to eat the traffic. Everybody following me there? This 10.8 value means that this 10 is the only thing that matters. Anything after that is just going to follow this rule. So when this 10.2 network, let's say it's this virtual machine, starts looking for this guy on a 10.1 network, he's actually going to route over here to this route table in the transit gateway. It's then going to match the 10.1 traffic to this rule, and then it's going to eat it. It's going to go into a black hole. It's going to be dropped, which means it's not going to redirect it over here. It's going to eat it. So that way, these two guys actually can't talk to each other because of that black hole rule that's in the route table down here. So just think of this as a catch-all that can allow you to eat traffic so you can prevent things from routing to each other. Now this EC2 instance, let's say it's going to the internet, which says, hey, I need you to talk to, right, outbound VPC, right? So the non-local traffic is actually going to get routed over to this outbound VPC. The route table in the private subnet for the outbound VPC routes all of its traffic to the NAT gateway. So this traffic is going to come out here to this NAT gateway. And the NAT gateway is going to route traffic to the internet gateway, and it's going to send it on to the internet. Weird, right? Now, if someone comes in and hits this transit gateway and they're looking for either 10.2 or 10.1, if it comes inbound, it's actually going to get routed to the VPC in question because the inbound traffic is actually hitting this route table. So notice there's different route tables for outbound traffic versus inbound traffic. These two are using this. If there was an inbound VPC, for example, it would be using this route table, which then says, hey, I'm going to talk to these guys. So this allows you, by the way, to control both the inbound and the outbound flow. It allows you to isolate VPC networks from each other. This is actually, it's pretty fundamental routing, which doesn't mean it's not complicated. It is complicated, right? But this is kind of the things people do with this kind of routing. Did that not make sense to anybody as far as why these two can't talk to each other because of this, or why this machine is going to go over here, which is going to go to the NAT gateway, which is going to go out to the internet gateway to get out to internet? Does that not make sense to anybody?
It makes sense. I think where it gets really interesting is that the outbound VPC seems to be like a separate networking account, right?
Mm-hmm.
Where some of the infrastructure stuff like NAT gateway and internet gateway is residing. And is that done from a cost perspective, or is it really an experiment at this point?
Well, what they're doing is that they're following a hub and spoke model for their networking setup, right? Which means that they're centralizing all of their outbound traffic out to this outbound VPC. And so while we only have two VPC client VPCs here, like the spokes, if you will, there could be 1,000 of these. There could be 100. Okay. There could be 50. That model is actually pretty common. The main reason was I think someone suggested it earlier, is that why would someone want to centralize all their network traffic, inbound or outbound, into a single VPC? And I can't remember who said it. Maybe it was Saif, maybe it was Brad, but like somebody said, hey, it's because of security, right? We want to do deep packet inspection. We want to like filter all the traffic. We want to capture every single packet that comes out of the system. We want a central place to look at all traffic, either going out or going into our VPCs.
I think that makes sense. The question I have is actually, by having or by not having a NAT gateway in each of the VPCs, would that save money?
Yes. If that's your question, absolutely. NAT gateways at a minimum. Does anyone know off the top of their head how much they cost per hour?
0.01545.
Yeah, it's like I think it's like 0.1, 0.15, something like that per hour. And you think that's not a big deal, but if you start running 15, 50 of these guys, plus the bandwidth that you're shoving across them, because you're going to get charged for bandwidth as well, right? What ends up happening is that when they're not being used, they're just sitting there racking up an hourly charge. NAT gateways are kind of one of the things people joke about, like, don't run them if you can get away with it, right? Because you're going to get charged an hourly costs. Just run everything inside of a public subnet and just make sure your security groups and firewalls are set up to just block everything, right? Because no one's going to get to your public subnets unless you will let them get to the public subnets. But this is one way you could get around that, is running everything through a NAT gateway just in a central account. So to your point, Gaurav, yes, it's a costing thing as well as security.
How resilient or how much availability is a single NAT gateway? What's the likelihood of it going down in terms of reliability?
Well, remember, the NAT gateway is a virtual device.
Yeah.
So it's not one device. It's actually however many devices they need from a bandwidth perspective. So the reason though that Amazon recommends that you run two is that it is a availability zone device. It's not a regional device, right? Load balancers are regional devices. If one availability zone goes down, the load balancer doesn't care, right? It's just going to keep on chugging. With a gateway runs in an availability zone. So if that data center crashes and everybody's running through that gateway, Even if they're in other availability zones, they're not going to get outbound. So this is why Amazon recommends at a minimum you run these AZ specific services across 2 AZs.
Right.
But in the AZ itself, it's super redundant. Outside of the AZ, it's not redundant.
Yeah.
So if you're going to ask a question.
No, it makes a lot of sense. Just that I'm just thinking about how much planning it would need to really manage it across. I mean, Brad's 35 accounts. So
Yeah, I would say that if you do not need to centralize everything for security reasons, which I gotta tell you, most enterprises do this, it drives me up the wall. They do centralize. If you're not centralizing, then just run everything in public subnets that are locked down. Again, people think because it's in a public subnet that automatically the internet can get to it. But if you don't assign an IP address to anything, guess what happens? Let me clear about that. If you don't assign a public IP address to everything in a public subnet, guess what happens? Nothing. It's a private subnet, right? It can still get to the internet, but if it doesn't have a public IP address attached to, say, a box or whatever, you can't get inbound to the system. You can't even see it. So just know that you don't have to give everything on a public subnet a public IP address. And without a public IP address, the internet can't get to your box. So that way you don't have to just deal with the complication of having private and public subnets. I know that's kind of counterintuitive because Amazon's like, hey, run everything into a private subnet. And that's true. But if you want to avoid this kind of headache, because the minute you start including private subnets, guess what has to happen? You need to have a proxy of some type to get to software, whether that's, you know, an apt repository or a Docker repository or all this other stuff, which you might have anyway, and it's totally appropriate. But the minute you start running private subnets, you have to look at NAT gateway as an option, right? So anyway, that was a little more practical than exam oriented. All right. Does everyone see now why transit gateway is the most horrible thing ever invented, that you never want to use it? No? Okay, good. Basically, at the end of the day, it's a great little routing service. It works spectacularly. It's approaching, I think, 2 years old at this point in time. My memory is horrible about these things because they just seem to release services every year. But it's been out for a minute. And we were all so excited when it came out. So, and I think at this point, I've converted all of my accounts off of VPC peering into Transit Gateway. So. All right, so let's talk about some best practices. First of all, you know, use a separate subnet for each Transit Gateway VPC attachment. In other words, you don't have to stick it into a subnet that you already have resources running in. Just create one, right? Just use like a /2027, /28, right? So you have, you know, more addresses, right? And just use a separate subnet, right? You know, just create the network access control list, keep them open, right? Just create a separate subnet for it. Remember, once you've create a subnet in an availability zone in an account, all the subnets in there will be able to talk to Transit Gateway or be attached to Transit Gateway. Make sure that you associate one network access control list to all the subnets associated with a Transit Gateway. So like maybe use the same access control list, because that can get weird and complicated, right? Use the security groups if you need to create custom access to the individual instances. Remember, security groups wrap around an EC2 instance, NACLs wrap around a subnet, right? So one of the recommendations they say is that if you're going to custom control access to resources from a security perspective, just use the security groups for the instances. Otherwise, use the same NACL for each subnet that's actually being used with the Transit Gateway. Transit gateways are highly available by design. So remember, these are regional services. So there really is no single failure point. If an availability zone goes down, the Transit Gateway is not going to be affected other than losing access to that AZ. Use BGP site-to-site connections, right? So what that means is that if you're going to do site-to-site VPN connections, make sure that you use dynamic routing basically and use BGP, turn it on. If your customer device or firewall supports like multipath, enable that feature as well. And then limit the number of Transit Gateway route tables you use. Remember, I said if human beings are really good at one thing, it's complicating things. So don't add an additional route table unless you actually have a really strong use case to do so. That could be security. At most, I think I've ever only added 3 route tables to a transit gateway for a really complex setup. So if you start adding 6, 7, 8, 9, you might as well have just done VPC peering at that point in time. I don't think there's anything else to say about that. Other best practices. Yeah. Some metrics to just pay attention to with the transit gateway is how many bytes are you pushing through it? How many packets are you pushing through it? You only get 5 transit gateways per region per account. You're limited to 20 route tables. You are only allowed 5,000 attachments per gateway. By the way, I think that with VPC peering, does anyone know the maximum number of VPCs you can peer with inside of a VPC peering if you use the old method? At last blush, it was 500. You might say, wow, Michael, that's a lot. Yeah, it is a lot. It's also a lot to manage individually. The cost, by the way, is per network that you attach to the transit gateway, plus the amount of bandwidth that's pushed through it, right? So do note that while the costs are pretty low, when you start getting into into petabytes and exabytes of data that you are pushing across, you're going to want to look at that because there's going to be some data charges associated with that routing. By the way, where are you going to look for all the key metrics if you want to find out how your transit gateway is performing? What's the name of the service that contains all the metrics in AWS? All the metrics. Where is it? Good. Just want to make sure you're paying attention. CloudWatch. Yeah. Which now, by the way, it would be CloudWatch metrics, because just in case you haven't looked at CloudWatch recently, there's 11 subservices under CloudWatch now. Yeah. Somebody got bored, right? There's there's logs, there's container insights, there's Lens, there's Lambda insights, there's Canary insights, there's alarms, there's all kinds dashboards, there's all kinds of stuff under there now. So if you haven't looked at CloudWatch lately, it's not the simple friend that you used to have. It's now a little more like a complicated frenemy, right? With a little bit more services underneath it. I did mention that there was a fabulous visualizer called the Gateway Network Manager that would allow you to see what's going on with your gateway services, right? So you can register transit gateways that are in your same AWS account. And once you register them, you basically have this visual monitoring tool. All of the attachments to the gateway will now then show up. Now, if you notice in the upper left-hand side, it says down VPN, up VPN, and paired VPN, peered connections, all colored, right? So notice it's got direct connects under connectivity up top. It's got VPNs up top as well. And it's showing you basically everything that it has connectivity to, both AWS and on-premise networks. So when you register a transit gateway, right, you can basically see everything attached to it. One thing to note, by the way, if you peer a gateway together, you still actually have to go in and register your additions. But if it's in the same region, it'll all show up. In other words, if you're in the same region and you register it with the network manager, it actually will do all of your attachments. When you peer with something that's in another region, for some reason, you have to go in and manually add all of your attachments. It's a little annoying, right? So says transit gateway attachments are automatically included. That's not true if you're pairing together. You do them manually. Let's see. Here, basically, they're showing broadband links, details about devices. It's basically registering like everything. So you create your network for the network manager, register your transit gateway, and you can actually define the details on your on-premise network sites, including like links, devices, whatnot. If you look up here, notice that on-premise, the little blue one at the top right-hand side said 16 sites and 50 devices. So it is actually showing that those exist. It's not necessarily monitoring them, just FYI. In other words, it can monitor the tunnel or the connection that it has with them, but because AWS can see that, but it can't really like see the metrics of the device itself. That should make sense to everybody. So if something goes down in your topology, you can actually see it. So like, for example, in this one, you can see that IP, VPN number 4 is actually has a down link. That's the one in red that's attached off of 2. That's a really blurry picture, actually. What slide is this? Let's fix that. Okay. Oh, the reachability analyzer. Yeah. This is a fun little tool. All right. So, obviously you get these situations where you've got like unintended configuration that can lead to issues. The reachability analyzer will allow you to analyze like the connectivity between 2 endpoints, but you don't have to send any packets. What it actually does is it looks at the configuration of all the resources between the 2 endpoints you specify and basically uses automated reasoning. Remember I said that. Automated reasoning. That's going to be the next AWS service, by the way, is automated reasoning. What this does is then checks all the configuration to make sure that the network flows are feasible based on the configuration, right? There is actually a reInvent talk about the algorithms that are used for this. There's also like a reachability paper, right? So what will happen is that at each level of this, it will actually look at its rule sets, its configuration, and see if network traffic can flow on the port and destination specified to the targets. So for example, this is an EC2 instance going to the internet gateway. So it's going to check all the configuration here to see what's possible. So this is only actually going to check for misconfiguration. It's not checking for faulty components, right? Questions?
So, like I have not used this tool too much, probably not that old. But what are the things we can consider as destination for this?
For example, it could be 2 EC2 instances. It could be an internet gateway. You could target a private link or a service endpoint, right? So you can add basically anything that can be like a traffic target on your like VPC.
Can it be like a public IP or like just like google.com?
Actually, it'll stop that at the internet gateway, right? It'll just
Okay.
verify that you're able to get out the internet gateway.
Okay, so if I put IZW, then that's that means
It's getting out.
Yeah.
Because beyond
Yeah.
that, it's not going to resolve DNS or website availability or any of that stuff. Good. All right, so that was just transit gateway that we just talked about. That was it. Let's talk about RAM next, and then we're talking about private link. All right, so let's talk about the resource access. Sorry, the RAM, right? Let's talk about the resource access manager. So with this one, we got VPCs owned by different accounts, and right now only the account owner of a transit gateway can attach VPCs. The operations manager is asking, how can we change this, right? So in this particular case, if you're not using the resource access manager, you've got an account owner, right? Because all AWS accounts have an account owner. Transit gateways are specific to an account. Users from other permissions do not have like permissions to attach VPCs to a transit gateway that's owned by another account. So how do we fix that? So the only account that owns a transit gateway can attach VPCs. Is there a way for us to share our transit gateway with another account so they can attach their VPC to it, right? Because remember, you have to own the VPC in order to attach, like accept a request to attach. So what happens here is that they're using the resource access manager. They're going to share a transit gateway across accounts. They're going to take the transit gateway and say, look, we're going to share it into account A, right? And what's going to happen then is that the VPC can then be attached into the transit gateway because it's now shared with that account. Now, A transit gateway, by the way, is not the only resource you can share with RAM. There's tons of resources you can share with the resource access manager, right? This basically, what this service does is it allows you to share a bunch of your AWS services with other accounts. That's all it does. Now, in this particular one with Transit Gateway, just so you know, a site-to-site VPN connection has to be the same account. You can't actually do that. But a direct connect gateway can be the same account or a different account. So just know that with VPN, you can't attach a VPN to a transit gateway that's in a different account. They just don't allow that. I don't know why. What you can do though, by the way, is peer transit gateways together from one account to another account. So if you are trying to get your VPN to talk to another transit gateway, you can just peer those transit gateways together, but you can't share that. There's a limitation. There are limitations. I guess my point in sharing this is that there are a bunch of resources that you are allowed to share with other accounts. So it's like, it's funny because you can't manage the resources with the RAM solution, but you can actually make those services available across another account. And this is some of the samples that you're allowed to do. And by the way, you can share to other accounts. You can share to organizational units, right? If they're part of an organization. And it does require permissions to share, right? Obviously, right? And by the way, you can share them with principals. You can share them with, you know, like I said, the account, the OUs. I don't know that I've seen other options actually. Accounts, OUs, or the organization, like you could share to the root OU, which is the entire organization. So that's just a little plug for RAM, right? I was trying to think of, I don't think I have that set up, but I used to. Where are you? I was looking at landing zone. Where's my AWS? Oh, did I close my AWS console? Hold on one second. Let's just take a quick look. Yeah, I think I stripped mine out actually. I did because I switched over to Ohio. Let's see if it's still in Virginia. Anyway, so like you can create a resource share. Let's just say this is test, for example. Let's say that you wanted to share either a subnet or like, look at the options here. Here's a resolver firewall group, which we talked about before. Here's some resolver rules, private certificate authorities. There's lots of items here. Image builder components or recipes, database clusters. You can share a bunch of things. Transit gateways are listed here. Outposts, that's interesting. I didn't know that was possible actually. App meshes, dedicated hosts, you got something locked down, co-build projects, capacity reservations. That's interesting, right? And then basically what you do is you share the resource, you show a permission, like who can access the resource, choose who can get access. So for example, let's say we're actually going to stick with a subnet because that's actually a pretty easy target. Let's see. Oh, there's no selected resources here. I could have sworn I had subnets here. Maybe I'll switch back to Ohio for this and see what happens. Let's leave the page. Did I somehow delete all my subnets? Sounds strange.
If we're sharing resources between accounts, how does billing work? Who gets billed?
Whoever creates the resource owns the resource. So you get billed for the usage of it. And some of the services like SQS, for example, you can actually charge the other person, but that's an older feature that most people don't have. So weird. Why are the resources not showing up? Must be doing something wrong here. Strange. Anyway, I wanted to show you like the principles you could choose, but for some reason I'm having trouble navigating because I've got subnets and it's telling me that the no resources are available. Weird. Huh. Anyway, what it then asks you basically, it says the principles you want to use. It says, hey, do you want to paste in an account ID? And then within that, you can actually choose an OU within a particular account ID, or if it's the management account, you can actually choose the root OU, which then becomes the organization, right? So it gives you 3 options for principals. So I apologize, I'm not sure exactly what's going on. I seem to have maybe broken something in my account, which is not unusual or common because I'm constantly in here tinkering. But something seems to be, maybe I stripped out all my subnets. That's a little strange. Don't think I would have done that, but maybe I did. Anyway, just know that the principals can be account, OU, or the entire organization. Notice that at mesh is referred to as mesh, Aurora actually referred to as database clusters, right? Dedicated hosts can be shared. Obviously, a variety of Route 53 components. So there's a bunch that can be shared using the RAM solution. All right, questions about RAM, just as a general concept of being able to share resources. I don't think this is on the exam yet. I haven't seen a single question about the resource access manager. So. All right, so let's talk about private link, and this will be our last thing before we roll into a lab. Get a little bit of a break. What options are there other than VPC peering? Like, what if we want to actually offer an internal service out to other AWS accounts, like to other customers in AWS? So with VPC endpoints, which we talked about before, you've seen this already, right? This allows you to talk through these either routing entities or a network interface to a public service, but going across Amazon's private backbone. Just a reminder, and you must absolutely know this for the exam, gateway endpoints only exist for S3 and DynamoDB. There are no other services that use gateway endpoints. The thing that gets weird is that every other service uses interface endpoints, but just for giggles, you can use interface endpoints for S3 and DynamoDB as well. The reason is by the way, is that they released gateway endpoints a couple years ago. The team that worked on them just stopped working on anything, other services. And then they started a new team that created interface endpoints. And they actually created basically these private NICs for all of the services, not just S3 and DynamoDB. And what happened is that they found out that the way they were doing it for gateway endpoints wasn't going to scale very well inside their organization. So they switched to a new team. So interface endpoints are for every service. Gateway endpoints are only for S3 and DynamoDB. Okay.
So worth knowing that for the exam, but from a practical standpoint, worth just using interface endpoints then for everything.
Yes. Yeah, absolutely. I don't know why they make a point of this on the exam, but they do. They try and trick you. You know, they'll say, hey, one of the answers will say, we're going to use systems manager with an interface with a gateway endpoint. I was like, well, and then the next one will say systems manager with an interface endpoint. Right. And so it's like, what are you actually testing for there? But that's just my weird criticism. Moving on. So yeah, gateway endpoints, right, are pretty much just know them for trivia. Everything else just use interface endpoints, right? The only advantage really that gateway endpoints could have over an interface endpoint is that they're not going to take an IP address out of your subnet. So if you're like desperate to have an S3 interface, like an S3 endpoint, and you have no IP addresses available for that inside your subnet, you could use the gateway endpoints if you really wanted to. I suspect Amazon's going to retire them though. So just FYI. Just like, by the way, the transit gateway, these endpoints that are listed here are virtual devices. They are horizontally scalable. They are redundant. They are highly available components inside the subnet, which means if the availability zone goes down, you need to go look at another one in another subnet, right? But within the subnet, they are highly scalable. They are HA, highly available. So here's where the discussion about private link, because that was just a review, right? We already talked about interface and gateway endpoints already. That was covered actually in associates, and we talked about it a little bit earlier. Private link is basically just an endpoint service. That's all it is. It allows you to create your own application in your VPC configure it as a private link service, and then share that service with other people who will request to connect to it. You approve their request, and then they can use your endpoint to get to your application. If you create a private link endpoint service, you are the service provider. You are offering a service via this NIC that you're going to share with other accounts. So let's say you have an EC2 instance that wants to connect to your shared service. It's going to route to your private link interface that you've approved them to access, and then they're going to get to your shared service. You might say, well, cool, Michael. How does that work exactly? Well, what happens is that the endpoint is going to get a DNS name. And by the way, there's going to be a security policy around that endpoint, right? We saw that, right? The very first lab, you saw that there was an access policy in the challenge, right? At the very end of the challenge, you had to add an access policy and modify it to be restrictive to one and not to the other as far as EC2 instances. The endpoint, by the way, is going to send the request, in this case, to a load balancer, which then is going to route to your service. So service owners can then register their network load balancers to the private link service and then provide these services to other customers. Now, what kind of services are we talking about? Well, EC2 could be behind there. You could send it to a Kinesis data stream. You could do service catalog. You could do systems manager. You can do SNS, right? Or you could do data sync. So here you could actually share this VPC endpoint to thousands of VPCs. Now, when they connect, by the way, you get a message saying, hey, are you allowing this VPC to connect? The answer is yes or no, right? And so then you got a security group for the connection. It does actually support overlapping addresses, just so you know, because it's going to do a little natting, right? And then it's only one-way access. So you can get a response, but it's not going to give you insight into their subnet. It only allows them to access your service, and you get to share a single service per VPC endpoint. You don't need firewall rules. You don't need path definitions. You don't need route tables. You don't need to configure an internet gateway. You don't need a VPC peering connection or a transit gateway. You don't have to manage the VPC IP overlap. Private link just makes that super simple. If they're looking for your service, they get routed to the VPC endpoint, and then it goes over the high-speed backbone and gets to the network load balancer, which then gets to the services in question that you want to connect to. That's it. So the steps for this are, you go to the console, choose a subnet that in your VPC that you're going to use for the interface endpoint. Your AWS is going to create the network interface endpoint in the subnet. You're going to create the endpoint in the console, right? And then you're going to specify the network load balancer that you created. You're going to grant permissions to consumers, either through a role or through an account. And then what's happening is that the person who wants to consume your service is going to create their own interface endpoint to your service. So you're publishing an interface endpoint called private link, and they're going to create an interface endpoint to link into your service. You have to accept and approve that connection for them to get connected to your published private link service. I make it sound that simple. Isn't it? Aren't there always problems when you go to set one of these things up? There are always problems, right? But it is actually, these are actually the steps. But you're kind of, you might miss something like the security groups are going to be set up wrong, or the word load balancer doesn't have the right setup. So, but these are the actual steps. Note that these endpoints, by the way, have endpoint policies. You saw this in lab 1 because the challenge had you setting up a policy to create restrictions. So no surprises there. Written in JSON, you already know how to do this. You've seen this already. But this defines who has access to the endpoint and how it can be used. So you get to control, and just to say this, if you don't attach one, AWS is going to attach a default policy allowed for you. By the way, when AWS attaches a default policy for you, that policy allows full access to the service, right? So just know also that if you choose a service that doesn't have like endpoint policies for some reason, Amazon's just going to grant full access to you, right? Just know that an endpoint policy on the endpoint does not override or replace any IAM identity-based policies. So in other words, if you're offering an S3 bucket on the back end and it's got a policy on it, and then you've got an endpoint that goes in, you have to get past the endpoints policies and you have to get past the S3 buckets policies. Just because you put another network card in front of a service doesn't mean that the security policies of that service are negated. They are still active. Okay. Couple of things to note. Make sure the security group that you choose for the endpoint will allow traffic to the service. Remember, these are NICs. Every NIC in AWS has a security group, right? Did we talk about that already? So make sure the security group has a hole in it that allows you to connect to the service. Notice it doesn't support IPv6. It's TCP only, if I remember correctly. Each interface endpoint is going to be capped out at 10 gigabits average, right? But can burst to 40 gigabytes per an entire availability zone. Oh, and it says it right there. Actually, I didn't even realize that endpoints do not support UDP traffic. If they can't be used to override for allow, can they be used for denial? Mohit, be specific. You mean this the endpoint policy? The endpoint policy can be used for denial.
Yes, Michael. So basically, you mentioned that they can't be used to override the policies, right? With IAM policies. So if they can't be override for allow, whether they can be basically used for deny. Let's
Just to say this, yeah. If anything's denies anything, that denial trumps everything.
Okay.
Yeah. Just to be clear, an explicit deny in any situation trumps any explicit allow. So if you got a deny in place at any point in the chain, whether it's a security group, the endpoint policy itself, or the actual identity like base policy for the service, like the user who's trying to access it doesn't have access. If there's a deny in any of those three places, user's not going to get access.
Okay. Got it.
Yeah. And you know, and I think we're used to that from Active Directory, right? If you got three groups, right? Like aggregate permissions will typically deny, will they not?
Yeah.
Yeah. So, okay, we gotta switch to a lab. I've been talking for like hours. I even really haven't been that entertaining. So we definitely have to move on. Okay, what cannot be attached to a transit gateway? Which of these cannot be attached to a transit gateway? It may seem like, by the way, that like this is a trick question. And it kind of is, actually. Yeah, direct connect terminates against a direct connect gateway. Right? So it doesn't actually terminate, like you can't terminate direct connect against a transit gateway, but you can connect a direct connect gateway to a transit gateway. Obviously, you can hook a VPC and you can attach a VPN to it because that's the whole purpose of transit gateway. But that's a little bit of a trick question because direct connect has to terminate, like the cable itself and all that has to terminate against a direct connect gateway. The gateway is what's attached to a transit gateway. Just to check, what is the name of the VIF interface that allows you to connect a direct connect gateway to a transit gateway? What's the name of the VIF? There we go. Good. Yes, the transit VIF, right? Just want to make sure we're clear about that. Okay. Private link creates a bidirectional access link from the service provider to the consumer. Sorry that I laughed there. Remember, I said, explicitly, just checking, right? That just because they have access to your service does not give you access to their subnet. It's a unidirectional link. Doesn't mean you can't respond to traffic when they initiate it, but you can't initiate a connection into their network. The network interface is only receiving traffic that is initiated. You cannot initiate traffic outbound across the network card.
So does bidirectional in this case is a technical term? Because technically traffic is bidirectional It just depends on who's initiating it.
Right. And that's typically what they refer to, is like who's initiating it, request and response. Right. As an example, if you want to get to GitHub across your corporate firewall, you can initiate a connection and they're going to allow the response, right? And that sounds like technically that's bidirectional traffic, but it's really not, because they're responding to a conversation you started, right?
Gotcha.
Yeah. And so almost all security devices like look at it from that perspective. They care about whether you're responding to an already allowed conversation or whether you're trying to initiate a new conversation. So that might be a better way to state this, is that it like bidirectional, like request response traffic, right? Would probably be a better way to qualify this question.
Okay.
But yeah, that's what they're looking for. Is it a security violation? That's what they're asking for with this question. And the answer is no.
Okay.
But in case you're wondering, Brad, you're right. Just in case you missed that, it could be better worded. All right, what is possible reason you could be blocked from attaching a VPC to a transit gateway? So this one's interesting. First of all, do resources have IAM permissions? Remember, we have identity-based policies and resource-based policies. But IAM is only for identity-based policies. So resources can't have identities. They can have resource-based policies, but they can't have identity-based policies. So the VPC can't have the correct IAM permissions. That's for users, groups, and roles, right? I'm not saying you couldn't assign a role to the VPC, but then that would be a different statement, because you can't assign a role to a VPC, just so we're upfront about it. So B is definitely off the table, because you're not going to assign identity-based policies to a service. You assign resource-based policies to a service, unless you're assigning a role, which is a different thing. VPC does not have a subnet in every availability zone in the region. Is that required, actually? Do you actually have to have a subnet, like a hook into every AZ into a VPC? No. The VPC is not using IPv6. Well, that's not required. It can support IPv4. Remember, the VPC is not from the same account as a transit gateway. I'm not saying that you can't hook a transit gateway to another account's transit gateway. You can do that. And that transit gateway, by the way, might have other VPCs attached to it. But when you attach a VPC to a transit gateway, it's going to be in the same region and it's going to be attached to the same account. So just a few caveats, right? Okay. Which statement is not true of transit gateways? Oh, actually, we made a stink on this one, so this is good. Hold on one second. Okay. Transit gateways can connect to a single subnet of VPC. You can peer transit gateways across regions. Yeah, you can do that. Highly available by default, you can do that. So like it's gonna be C, possibly D, right? Now, Brad and I had an interesting conversation where I made a distinction between routing and peering, right? And I said that if you want to have two transit gateways within the same region talk to each other, that you had to route between them, right? But if you want to connect a transit gateway to a transit gateway in another region, you had to peer it, right? So you can peer transit gateways within a region. You cannot actually. You can route between the two transit gateways in the same region, but you can't peer two transit gateways in the same region. You can't peer them together. You can have them route traffic to each other, but they can't be peered. There's no reason to peer them. They're already in the same region. They can already talk to each other. So D is the one that is not true. Because remember, you actually can connect a transit gateway to a single subnet inside of a VPC. Remember, you don't have to use all the VPCs. You don't have to use all the subnets, right? You can go specific to what you want. All right, questions. All right, let's talk about lab 2. Somewhere in here, you're going to sneak a break, right? All right, here's what we're going to do is that with the Transit Gateway, we're going to do this first lab. We're going to take about 30 or 45 minutes to run through this. It might be longer, it just depends. But I'm hoping we can actually squeeze in some questions today. It sounds like we might be squeezing right into that, but hopefully we'll get at least 15 or 20 minutes because I want to talk about question strategies with you. So here's what we're going to do, right? Here's the whole setup. We got a primary region, we got a remote region with a transit gateway, we got a bunch of VPCs. Notice that one of them has an internet gateway on it. Here's what's going to happen. We're going to review the network topology. We're going to create a transit gateway. We're going to attach VPCs and whatnot to the transit gateway. We're going to create a transit gateway route table. We're going to update the route tables for the VPCs that are here. And then we're going to create a peering connection between the transit gateways. Then we're going to create some route filters. And then optionally, we're going to allow you to visualize and analyze your network using the network manager. Okay. So if you haven't already done it, come on out here to webage.quicklabs.com and go ahead and open your lab and hit that start button. So if you haven't done it already, go ahead and hit start lab. It should start right up. So let's go ahead and kick the tires on this. Please, when you're done, either just post it in chat or just use the green reactions box and click yes, right? So good. Oh, thanks, Andrew. That's good to know. But this we're going to be doing for the next, like, let's say 45 minutes. So let's stop at 1:15, even if it runs us a little bit over as far as like you having to pause the labs for a second. I really want to spend the last 15 minutes talking about these question strategies just to get this embedded in your head. And then you can spend some time running through the questions on your own time or do labs, whatever. Okay. So you're now at your own free lab time. We're doing lab 2, configuring transit gateway. I'm right here. If you have any questions, you just let me know. Okay. Let's get it. All right. So let's talk about the, let's do a review mode exam. Let's go ahead and do set 1. We'll resume this. Don't forget this blazingly fast. Click through. I tell you what, though, once you're in the test, it works great. It's just for some reason, I think it's navigation. I always wonder if it's me, actually. Maybe you're all having a different experience. Worth it. Totally worth it, John. God, I wish your tests weren't so good.
And easy to use an edge location, eh?
Seriously. John, let's talk about this, man. Am I getting all your static content cached? Because it should be cached. Although, you know, it could be me. Honestly, I've been having with the water thing and the gas thing, I've been having weird internet. Like I mentioned earlier, like it was saying my internet connectivity was weird. And you know what that involves? That involves a geek basically tearing apart his entire network and starting over, right? Because that's what's going to happen. Because that's what we do when we're engineers, is we over engineer. So, all right, let's try this again. That is unusual. There we go. Okay. So when we start these tests, a couple things to think about is that one, make sure, and I know this is going to sound absolutely trite, please read the question. If you're taking the practice exam and you're distracted and you don't have time to focus, then don't, like, I'm just going to tell you this, don't bother. Come back when you have time to focus. Because if you're not going to read the question and you think you're just going to skim it and that's going to be useful practice time, I'm sorry, it's not. I wish it was. I wish I had another thing to offer you, but I don't. If you can't read the question in its entirety because your brain's somewhere else, you're distracted, just skip it. Like walk away and come back. And the reason I say that is I can't tell you how many times I've failed questions because I forgot to read the entire thing. Right. And that's true for the practice exams and the actual exams. Now, I think I've only failed like one exam in my entire career, but regardless, I've failed questions because I wasn't paying attention. So make sure you read the whole thing. And if you don't have time for that, you're thinking to yourself, I don't have time for that. I'm really frazzled. You need to go shift your state and then come back. So remember, when you go take this in the exam, meditate, take a deep breath, pray, whatever you believe in. I'm not here to judge. I'm just going to tell you, make sure that your nervous system is right here. Focus on these questions. Because if you miss a word like effective or simple or scalability, the answer is going to be completely different. Okay. So, company wants to create a new service that will complement the launch of its new product. The site must be highly available. Boom. That's one requirement. It's got to be highly available. Note that in your brain. Second, it must be scalable. Boom. Note that it needs to be highly available and scalable. Those are key requirements that are going to inform your answer. Second, you have an unpredictable workload. When you see words like that, these are all going to stack into your answer. You see now why this is the professional exam. They're going to give you 5 or 6 things that you're going to have to remember around the requirement. And of course, you can't write anything down, and that's true whether you take it in person or proctored, right? It also needs to be stateless and REST compliant. In addition, it has to have multiple persistent storage layers for service object metadata and durable storage for static content. All requests should be authenticated and securely processed. They also want to keep costs at a minimum. Could they ask for anything else? Let's recap. Highly available, scalable, stateless, RESTful compliant, and it need to be able to handle an unpredictable workload. They want multiple persistent storage layers, and they want it to be durable for static content. Everything should be authenticated and securely processed, and they want to do it as cheaply as possible. So to me, they just pretty much just asked for everything, right? So then what are they looking for, right? They want a new service to launch their new product that meets all those requirements. What are we going to do? First of all, with a question like that, you may not have an answer that just pops off the top of your head, right? So if you do, great. If you don't, then first just know that they're probably going to present 2 or 3 of the same type of answer. So all you need to do is eliminate one of the sets. What do I mean by that? First of all, these 2 answers are basically Docker-based with using Fargate service. This one's using an API gateway. If you know one of these is wrong just from the first sentence, you can eliminate that from your answer set. But first of all, is one of these wrong? I don't know. Let's see.
I feel like they're not going to suggest that you start by packaging a REST service on a Docker-based container.
Yeah,
It's a little too complex for the easy Amazon solution. Not wrong.
Well,
that's the only part I read about that answer yet.
But let me ask you this. Is it going to be easier than creating a bunch of unique Lambda functions to process each resource?
I haven't gotten that far yet. There's a lot of words here.
Right, because
I feel sketchy. Answer B, I feel a little sketchy about.
Feel sketchy about it. But so remember, there's no clear evidentiary qualifiers for the first sentence. So there's nothing actually here that's actually standing out. I hear you, Andrew. You're saying like, I don't really feel like they would recommend a Docker container, but it's using their services. So they actually would recommend a Docker container if it was using their service. So thus far between the answers, we don't have a clear differentiator, right? Is that the second sentence says, let's create a cross-zone application load balancer in front of the Fargate service. They both say that. Let's create a custom authenticator that will control access to the API, or do we use the Cognito pools? Okay, so that's a little bit of a flag right there. Let's store the metadata in DynamoDB with autoscaling enabled. So that says the same thing. Let's create an encrypted Amazon bucket to store the static content. Let's create a bucket to store the static content. Let's generate pre-signed URLs when referencing objects. Let's proxy data through the REST service. Okay.
I had one of these questions earlier today when I was looking where one of the sentences was the same on all 4. I don't quite see that here, but then I'm like, oh, that doesn't help me. You know, like I try to break it out into all the different pieces, and one of them was identical on all 4 of them. Oh, well, okay.
Right. So notice then that they do the same thing with this set of answers, is that pretty much it's the same thing, but notice what changes. Control user access using Cognito user pools versus using a custom authorizer. The rest of this, well, this is Elasticache versus DynamoDB, right? This is a secured bucket, generate pre-signed URLs, right? So here, first of all, we're not going to use Elasticache for storing metadata. So this one's out, right? The fact that, by the way, that this doesn't have a secure bucket, this kind of like makes me want to rule this one out, right? It doesn't have a secure bucket. It's not creating an encrypted Amazon bucket. So now we're down to these two particular answers. So then what we're really looking at here at this point, sorry, not these two. We're down to these two answers. So both are using Cognito, both are using DynamoDB, both are using a secured Amazon S3 bucket. One is actually using pre-signed URLs, the other one's using pre-signed URLs. So then what's the only difference between these two answers? One is using a Docker container, one's using an API gateway, correct?
Yeah, did the question say something about how many API, like how large the thing was?
No. So it's going to be highly available, scalable to handle unpredictable workloads. It should be stateless and REST compliant.
But that
Is that-
doesn't mean
Which would be
a lot
Lambda.
of endpoints, right?
Right. In other words, it's not really giving us a clear set, right? But let me just say this. Statelessness is typically, right, and I hear what you're saying, is like some of you are going, but hold on. We can actually do this with basically Lambda functions, but this is actually using a gateway custom authorizer, right? Do we actually need that, or could we just use Cognito?
Why wouldn't you use the lower Lambda one with Cognito?
Well, that's what we are. So it's either this answer or this answer. These are the two that we centered on, right? Basically what I did is I eliminated these two because they're not using secure buckets, and this one's also using Elasticache, right? Which we're not going to use to store object metadata. I guess my point in saying all that is that I'm revealing to you what Amazon, like Amazon's not going to use Elasticache to store DynamoDB metadata. They're just not going to do that. It's not what Elasticache is designed for. From their perspective, Elasticache is only used for caching like database data or session data. You wouldn't store persistent data inside of Elasticache. It's a cache. So this is why I eliminated this answer out, right? Then now I wanted to service that to you so you can understand how I eliminated these relatively complex answers. The other thing that I'm eliminating is that we're creating a custom authenticator to control access to the API. We don't need to do that. I don't need to basically control user access using a custom authorizer. I could probably use Cognito user pools to control access to the API, could I not? Because API gateway and Docker could use Cognito to hook in. And then Mohit just hit it over the line, right? As far as understanding cost, because that was the very last thing they mentioned was keeping costs to a minimum, is that running a container will be a persistent cost. Running everything in a Lambda with a flat proxy in front is going to be a much cheaper option, right? Now, we just did all that reasoning, by the way, and we could be 100% wrong, but I guess I'm showing you that the things I actually have said are actually appropriate. And Mohit's, we got a good point, is that Docker is a 24/7 running solution. This one basically is going to be really flat when it comes to costs. So let's take a look. Let's take a gamble.
And if
Because we
you
could
use Docker, you want to auto scale that, you need probably a load balancer then too, right? Which is more expensive.
Exactly. You also have a load balancer in front of the service, right? Funny thing about an API gateway, guess what? It already acts as, in a sense, as a load balancer, right? So let's check it out and see if we're headed in the right direction, because we could be completely wrong, but we're not, right? So notice that we had to peel back multiple layers. If you didn't know that DynamoDB, I'm sorry, if you didn't know that Elasticache wasn't used for permanent data storage, you might think that this was the answer. If you didn't know that the custom authorizer is a very cumbersome thing to set up, right? You might think that that's something that you're actually going to do. If you didn't know that Cognito integrates in, right, with API gateway, then you might not know that that might be something you can use. And of course, if you didn't consider the last question, just to use Mohit's thing, right? If you didn't consider the last question about costs, you might actually think that Docker might be a better option because it's more scalable, but to his point, it's more expensive. Both are scalable, but Docker's more expensive. My point in pointing all of that to you is that I want you to take your time when you take these questions, and I actually want you to do comparative analysis. Not just to eliminate answers, but to confirm what you know and what you don't know. Because if we had gotten this wrong, you need to make sure that you take the time to read these answers to understand why, because it's going to tell you, for example, that though this scenario could possibly work, right? Lambda is cheaper. right? To your points. Running a Fargate gunner continuously is more expensive, right? In other words, this would work, but it's more expensive, right? The other thing is that it would recommend that you use Cognito instead of doing a custom authorizer. Amazon's going to want you to lower your work threshold, right? They don't want you to eat all that complexity, okay? So when you do your questions over the next 24 hours before we meet again at 9 o'clock, because I'm going to let you go because we're over time, I want you to do a comparative analysis. Even if you only do 5 questions, but you methodically run through what you do and do not know about the services, go ahead and answer the question wrong and then figure out where you went awry, right? Because I want you to start figuring out how to correct your reasoning because it's going to teach you so much about how to pass the exam. I know you think it's going to be like, it's like, well, Michael, that's slowing us down. Yeah, no, I know, right? I want to increase the quality of the study that you're getting, increase the correction of your reasoning. If you run through 100 questions and you don't learn half as much, that's not going to be worth it, okay? So your homework, if you can get a chance, either tonight or tomorrow, because I know for some of you, it's the end of the day, run through at least 5 to 10 questions and do some comparative reasoning. If you could need to write it down, write it down. You can practice keeping it in your brain later on, okay? That's the main thing I wanted to kind of like showcase to you today is you've got to methodically look at this, capture the requirements, match what you know about the services against the requirements, and just keep them in mind. And make sure you're answering every question. The last question they ask, Mohit, that was perfect, by the way. You teed that up. The last question they ask is typically the one that's most important to them. Make sure it's cost effective. Make sure it's simple. Whatever the last question is typically the one they care about the most and will be the tiebreaker. Okay. All right. Thank you for sticking with me. I know you all have like 1,000 other things going on. I know it's the end of the night for some of you. We're done. I'm going to hang out for just like 2 more minutes in case somebody has a question. Otherwise, go off and either go to bed, go with your families, or go to reInvent, wherever you're doing. And I'll see you tomorrow at 9 o'clock. Okay.
Thanks.
Quick question
Yeah.
for you, Michael. For Pearson VUE, I feel like they had a note section you could write in. Do you know offhand, or could we look that up somehow?
So the last exams I've taken hasn't had a note section.
Okay.
Yeah, and they stopped giving you the pieces of paper that you could do the dry erase on. They stopped doing that as well. So I don't know why.
Oh.
I actually put an email in to them, but they never answered me. So I was having to go to reInvent just to harass them. I have a question for you, learning and development. Why did you take away our ability to write something down?
Yeah, they are here. I think I saw them at one of the booths. I'll have to go ask.
Yeah, ask them. Hey, a coworker of mine, a friend of mine, was just telling me that like we can't write things down inside the exams. We can't do it either digitally in the proctored or in person. Did something change? What happened? Just kind of curious as to what they say. Yeah.
Cool.
Well, have fun tonight. I don't know what kind of shenanigans they're having over there, but I'm watching Corey Quinn kind of tear it up. So
I'm not doing any of the shenanigans other than this.
oh yeah. So you're not getting to go to any of the
I'm
keynotes?
going for sure, but in terms of like all the social other quirky events, like in the evening, like so I'll go to session study, go to a session study, but all the evening things now because of this priority.
Yeah. And actually that probably makes sense. I have a bunch of friends who work for the CDC. Yeah, probably better off to stay inside and not to spread fear, uncertainty, and doubt. People are remarkably safe, but I think a little bit of extra caution, at least for a few more weeks, is going to be warranted. So yeah, Omicron is here. It sounds like a transformer and it's not.
Yeah. I don't like being sick anyways, so.
Yeah, me neither. Although I haven't gotten sick. I haven't had the flu since this whole thing started.
Yep.
So yeah. All right, everyone.
All right. Watch it tomorrow.
Yeah, we'll see you tomorrow. Saran, Shyam, Parth, Mohit, thank you. Vikas, we will see you tomorrow.
And,